All right, how's it going, everyone? This is Brian Huff, and we are going to be going through a mini series on Solidity and writing smart contracts on the blockchain. Web3 and blockchain technology development is one of the fastest growing fields right now, and it's not slowing down anytime soon. And the reason is that blockchain and decentralization is taking over how data works amongst people, amongst systems, amongst networks, and it's completely changing how we work with companies, we work with individuals, how we identify online and on the web. And it is just such an exciting field. So we are going to be going through a lot today in a very short amount of time. We're going to be going through really what the tech stack is for Web3. We're going to be going through what a wallet is. We're going to be understanding how smart contracts and Solidity work, and really just understanding how we can build our first decentralized application. So I hope you are ready. Definitely, if you have your phone, definitely put that on Do Not Disturb, put your phone down. We're going to be really focused right now on how blockchain works and really focus down on how we can build the skills that are rapidly transforming industries around the world, how you can level up as a developer and become that Web3 blockchain engineer and get either a really maybe high paying job if that's something that you're going after. Maybe you build a really exciting startup. Maybe you just are interested in this technology and you want to build an NFT collection or build a decentralized application or a dApp. All of this is possible if you put in the right work and have the right mindset. So I'm really excited to help you on your journey into Web3. So without further ado, let's get started. All right, so to give a little bit of context, I have been in the space since 2018. I had a very cool opportunity coming out of college. I went to be with a colleague. She was working at a blockchain VC fund, and they needed some help with marketing and branding. So I, of course, did not know anything about blockchain at the time. I was just sort of really just getting involved in technology a little bit. I was with my work when I was working at the Harvard Kennedy School, but I had never really even heard of blockchain at the time. And my friend says, "Oh yeah, well, it's about these nodes and it's this decentralized network and it's basically internet 3.0." And I was like, what's internet 2.0? So I've definitely seen a lot in the space, and a lot of where our investment thesis was around layer 2 solutions, specifically on Ethereum, but solutions that are built on top of a network. So if you think of the internet in your normal day, sort of you might be going on Amazon or you might be going on Facebook or Instagram. Those are technically layer 2 solutions on top of the public internet that we all use. So what we were investing in was specifically layer 2 solutions on top of a blockchain network like Ethereum. And then they might have like side chains, which are protocols built on top of the network that maybe make it more efficient or maybe help solve some sort of inefficiency. So I've been in space since 2018. A lot has happened since then, and I got really into tech through going to hackathons. So I sort of postmark my start date of getting involved in development in 2019. I went to ETH Boston, which was ETH Global's hackathon in Boston, and I was hosted at Harvard, and it was an amazing experience, but I did not know anything about coding. I did not know about Yarn or NPM. I was really just there to learn and to be exposed into the tech. I had been doing marketing and in communications and sort of an advocacy for our portfolio projects, but I wanted to know more about the actual technology. So one thing led to another. I started, going to boot camps. I did Udacity's blockchain developer nano degree, which I highly recommend. And I really just started going on Udemy, going on YouTube. There weren't a lot of tutorials and a lot of knowledge that was out there. It was very hard to find content online. So a lot has changed now and it's much more accessible in a sense, but there was really not a lot at the time. So I was sort of going to work. I was working in PR and marketing, but then in the evenings and on weekends, I was learning how to code. So I've spent really the last 3 years learning blockchain development and then also cloud development. So I'm also an AWS community builder. I work a lot with the AWS serverless tools from like servers, frameworks, building serverless technologies, APIs. And then on blockchain, I currently work as a Web3 developer. I also advise on NFT and crypto strategy, and also advising on integrations of technologies and also building dApps. And dApps are decentralized applications, as well as apps, which are just, cloud-based applications, or maybe runs on a server or something like that. So I've just been really, really, really loving Sunny's courses and all of his trainings. I really love the Papa Fam, and I'm really excited to be sharing with you all something that I've been really studying for the past few years, this technology that is rapidly transforming our world. So hopefully that gives a little bit of context to where I'm coming from. And I've definitely seen a lot in the space. I even just think of how NFTs are not today what they were, 3 years ago. I remember getting my first NFT back in 2019 when I went to ETH Boston. They give an NFT to everyone that attends the hackathons. So I got one, and I really didn't even understand what that meant. I knew that I had received one in my wallet, but I didn't even really understand what a wallet was. I kind of used it a little bit, but I didn't really understand much about it. So hopefully I can kind of get you farther running with these technologies and also help you understand a little bit more of this exciting space. And yeah, so I'll get right into our agenda and then we'll be able to get started. All right, so we have quite a lot on our agenda here. We are going to be, first of all, welcoming you to Web3. WAGMI is a kind of like a rally cry in crypto. It just means we are going to make it. So you'll sort of see like hashtag WAGMI or just WAGMI, maybe with like a rocket emoji. So that's just what that means. But then we're going to be going over what a wallet is. We're going to be going through what an address is. We're also going to be talking about what the Ethereum blockchain looks like, looking at a tool called Etherscan. We're then going to be learning about Truffle and Hardhat to test blockchain environments locally. And then we're also going to be having an intro into our first dApp. We're going to be learning about Solidity, which is the native programming language of the Ethereum blockchain. And then we're also going to be building our first state change dApp. And I'm going to be explaining to you what that exactly means, but that's going to be our first application. That's a decentralized one. And dApp is just decentralized application, but people will often call them dApps to differentiate them from apps, which would be sort of a Web 2 or a cloud-based application or a server-based application. So yeah, we're definitely going to be going through a lot of these things. And of course, definitely reach out to me if you ever have any questions. This is my social media handle. If you ever want to like drop me a line, I'm also on LinkedIn. I'm pretty active on LinkedIn. So if you ever have questions, feel free to drop me. I'm also pretty active in the Discord and Slack channel. So just feel free to @me in there, and then I'll be able to respond. And just a little bit of a thing, just a cool thing with blockchain. So this is not a website, but this is a wallet identity. So there's a project called ENS, which is the Ethereum name service. And in the same way that you might purchase a, papafam.com or something like that, that would be a domain name. You can get an ETH domain name. And instead of it being pointing to a website or a file that's maybe an HTML file on the web, this will point to a wallet. So this is pointing to a specific one of the wallets that I have, and you can use this to make it way easier to send like crypto transactions or NFTs or just really identify online with the blockchain. So just kind of a cool thing. So I had purchased this NFT, and there's not really a price associated with these NFTs. It's really just, I think it's like $20. It would be like to buy a domain name, but then you get this, and then you can have your Ethereum address point to that specific point. So instead of having to point, and I'll show this to you later, but there's like, it might be like 0x1234, 1234, a whole series of characters for your actual Ethereum address. Similar to like binary, might be like 1010, etc. You'd be able to just have, brianhhuff.eth as your domain name. So just kind of a cool little thing that I wanted to throw in there of showing how you could potentially buy an NFT, and then that could be, something that you could use as a utility, as well as social media, right? You have your handle, and that points to your identity on that social media platform. This is your identity, but on Web3, on blockchain, specifically with Ethereum. So I just wanted to throw that out there, just a little bit of an interesting and kind of just show you different ways of how blockchain can identify yourself online. So if this is your first experience with blockchain, Web3, NFTs, crypto, or really just decentralization, or maybe you've heard about it for, a little bit. You've maybe seen it on Twitter, maybe you've seen it on, in the news, or maybe you saw someone, a family member was talking about it or something like that, or maybe a friend. But either way, I want to welcome you to Web3. Wherever stage you are, this is a really early industry. You're getting in at the ground floor. And what is super special about Web3 and technologies, similar to cloud, when cloud was first taking off, there were people that were early adopters of that technology. Now, Amazon, for example, Facebook, let's even think about Apple has technologies. Everyone is in Netflix, for example. Everyone is building on cloud. Even like NVIDIA, right, for like supercomputers, like there's certain elements that they are building with edge computing, and that works on the cloud. So, there are, billion-dollar businesses that have been built on the cloud, and now there's becoming more and more of these, hundreds of millions, billion-dollar companies that are tokenizing assets, putting things on the blockchain, and building real infrastructure around decentralization. So whatever stage you are, I want to welcome you to this exciting space. I also want to show you an article that was published by CoinDesk in 2020. And I'll pull it up right here. So just so you can see that there is this article, and it's in the business section, but I'd highly recommend checking it out. I did spare you from having to read it yourself. So I do have some notes that are taken on it, but I wanted to really highlight a few things just from this article. So this was back in 2020, and it was reviewing the last year. And cloud computing, AI, analytical reasoning were the global most requested hard skills. And these are specific because you're all looking at building infrastructure and around technology. But specifically, blockchain emerged as one of the top skills that's solving business problems. And that's why it was ranked as one of the top skills for 2020 in LinkedIn's job report, because people are getting hired at fast rates because they need in-demand skills. And that's what I think when I think about just Sunny with Papa Fam, giving people really in-demand skills like understanding React, understanding Next, understanding Firebase, understanding cloud computing, and understanding how databases work and how you can upload files to the front end. Those are so important because that's how you build apps, that's how you build software, and that's how you get hired. So what's really cool about specifically this space is that we're so early right now in understanding that blockchain isn't just this shadowy world of, cryptocurrency like a lot of people were sort of pretending it to be, but it's really cryptography. And if you've ever made purchases online and you were giving your financial information, or maybe you were verifying your bank account and you use Plaid, for example, any of these integrations or any of these payment protocols like Stripe is another one, or Cash App, they're probably using SHA-256, which is just a cryptographic hash algorithm that basically helps to encrypt and store data and process it. Blockchain is a similar type of cryptography, but it's for decentralized peer-to-peer networks, for example, or Oracles is another example of blockchain where it allows to decentralize different types of sort of creating like trustless environments where you don't necessarily need to know the parties that you're working with, but you know that you can trust them because the system is able to verify information and validate information without you needing a person to go. So people that understand these technologies are getting hired at fast rates. And I do also just want to give you a little bit of an exploration into what blockchain is, because I think, and I refer to this infographic so much because it's so important to just understand really, and this is created by Real World, but it's really to understand the real world understandings of what's happening at blockchain. It's not just cryptography, it's not or cryptocurrency, it's not just NFTs. There are huge companies that are being built into this, and if you kind of even like go into this, so there's Bitcoin, which is sort of a payment protocol, right? There's Tezos, which is another one. Ethereum, which is for building dApps, decentralized applications. Neo is another one. Ripple for banking. Hyperledger Fabric, it's a more like a private permissioned distributed ledger technology database. There is Infura, which is a tool for that. There's a ton of different projects, and these are all public and private blockchains and mixed. Then enter in cryptocurrencies. So that's where you might get Monero, which is a privacy coin. You might get Bitcoin Cash, which is a fork of Bitcoin. Ethereum as a coin, and also there's different ones like Litecoin, for example, here, Decred. Even Tether, TrueUSD. US dollar stablecoin. There's stablecoins for asset storage. There's storage. There's SIA. There's Filecoin for data storage. It also would be Filebase that's in here. IPFS. And there's these protocols that are being built on this. So this is just storage, distributed computing. This is middleware services. So Stellar. There's EOS. There's Tron, Ripple, 0x protocol, Icon, Cardano. Really, there's a ton of stuff. Ethereum Classic, Quantum. There's all of these protocols that are being built. Now, let's go out a layer outside of this. There's now exchanges and trading. So ones that are built on top of these cryptocurrencies. So there's BitMEX, there's Binance, Coinbase is in here. So Coinbase right here, Huobi, T0, there's Gemini, Bittrex, Bitstamp, OKX, Crypto.com would be in here too. Now let's go to wallets, right? So there's Trezor, which is hardware wallet. There's Ledger. There would be BitGo. MetaMask would be in here. MetaMask is here under DevTools. It's a wallet, but also it provides sort of node for working and stuff. There's Lisk. Now for ad tech, there's Basic Attention Token. There's ICO Box. There's different prediction markets. Augur is a sort of big one. There is also utilities. There's insurance and healthcare. There is integrity. There is legal. Aragon, for example, actually really interesting because this was made several years ago. Aragon is used in voting for DAOs. So DAOs are decentralized autonomous organizations. And what's really interesting about DAOs is those are structures to build governance around an NFT community or a crypto community. And those are actively becoming very transparent public ways of organization and structure. Similar to you have an LLC or a C Corp or an S Corp. You could also have a DAO, and a DAO is just a more formalized, transparent, blockchain-based organization with rules and structures. But in GovTech, there's Flux, Democracy, BitNation. There's tons of different ones with financial services. Nexo. There's tons of different ones. Salt, Bancor. There's a ton of these different ones. Now go out even a layer further with ATMs. So this is how you get like the Bitcoin ATM. There's video and game dev tech. There is, and LivePeer, actually, I was just working with them on a project. It's for video streaming, for example. Browsers, there would be the Brave browser. So Brave would be here, and that is built on basic attention token. So you could build hardware on top of these software on the blockchain. There's also social networks, such as Steemit is pretty popular. Kik. And I know also with PapaFam, they had created Clouch, so that would probably go under social networks as well. Under analytics and resources, there's CoinDesk, there is Cointelegraph, and we actually were just reading an article from CoinDesk earlier. There's also CoinGecko, Token Market, ICO Alert, and even under asset management, there's eToro. If you follow sports, they were doing a lot of advertisements, specifically last year and also this year, sort of targeting the sports world. And there's also Grayscale. They have a ETF on the stock market related to Bitcoin. So they've been making a lot of moves there. And also Pantera, one of the largest crypto investors in the space. There's also Draper Gorham Holm. They're another big player in the space that emerged a few years ago. This is just sort of a little bit of a map of what's really going on in the space. And also, this is sort of a outdated map. This would be sort of looking a little bit different if we were to create one of these today. But a lot of these names, the majority of these names are still in existence. And also just want to show you that it's more than just cryptocurrencies. It's more than just NFTs. There are fully fledged out global companies that are built and are existing and are scaling very, very fast, rapidly, that are built on a lot of just a few technologies, similar to how you'd have Firebase and you build a company that's built on Firebase. There's so many companies that are built on, AWS or Firebase or Azure on Microsoft. There's so many different companies that are being built on cloud technologies. So these are just companies that are being built on blockchain technologies. So in a similar way. So that's really just sort of those two infographics that I wanted to show you. That's the first one. And then this is just another one from Scale. Scale is a layer 2 solution built on Ethereum. And just to sort of show you that around Ethereum, there are validator networks that help to bring, safety and security to the blockchain network. But there's also data explorers such as the Graph or Covalent, which is an API for blockchain. There's also oracles such as Chainlink. There's different token standards. We did one that was an ERC20 token, which was a workshop for PopFam members earlier. And I showed you how to make your own ERC20 cryptocurrency. ERC721 is for NFTs. And there's different ones. There's 1155, which is now sort of a more popular one for there's different use cases for these different tokens, but mainly cryptocurrency is 20 and ER721 is for NFTs. There's also developer tools, Remix. We're going to be using Remix and Truffle later. Also Web3.js. And then there's different protocols, like there's Maker. They also have MakerDAO. For wallets, there's Taurus, MetaMask. There's also Formatic, Portis. And stablecoins, Tether and USDC are very popular. There's also API connectors such as Infura. Alchemy would be another one that's become very popular over the last year for storage. There's also Arweave. And for dApp categories, so many different categories. There's health and biotech, IoT, marketplaces, music, games, supply chain, content streaming, social, marketing, tech, nonprofit, and micropayments. And then the end users. So these are the, millions and millions and millions of people around the world that are ready for these technologies. So you can build something and then use this whole ecosystem of technologies that are available to you to really scale something special. And that's why blockchain is so important and so special, because people are actively building in the space, building real solutions that are solving real problems. So this just hopefully gives you a little bit of context around really what's happening in the blockchain space. It's not just prices, and it's not just, this went up or this went down and day trading. And I think that sort of gets unfairly categorized as the whole industry. This is something that is rapidly building technology infrastructure, core networks around these tools. So when we think of a wallet, I want us to think of a wallet as just an identity and access manager for dApps. In the same way that you would log into a web application in the cloud or with a server and you have an email and a password, a wallet is that way of you identifying yourself to a system. So with dApps, decentralized applications, this is how you're able to now interact with them. And you might have a store of value that might be data that's in your wallet, and that's what you're giving to the website to authenticate something or prove that you are who you say you are. You also might have cryptocurrency, or you might have assets in there, and that might be an NFT, it might be crypto, it might be some sort of monetary asset, and that's going to be allowing you to maybe make a payment through a protocol or through a dApp. So it's really just your account manager that allows you to authenticate yourself, contribute to the platform, and give it value. Now, there's just a couple things to note about wallets. They're really easy to think about. There is a public key and a private key. The public key is your address, and that is what you'd use to identify yourself, receive crypto or send crypto, or really just interact with any protocol. And it's going to look maybe something like this. And this is just like a string of characters that comes typically after 0x. That's what for Ethereum specifically, but there's a lot of wallets that model the same type of string character count. And this is going to be how you would send this. So if you wanted to have someone send you cryptocurrency, or you wanted to log into an application, this is what the wallet is going to send to that application to be able to say, okay, here is that address, and we're going to know that this is the specific address we want to interact with. Now, there is also a private key, and this is specifically your seed phrase. This is sort of the password to the entire wallet. You never, ever, ever want to share this with anyone. I really want to emphasize that. You never want to give that to anyone. This is basically like giving someone the key to your house or your password into an important account that you own. And specifically when you log into MetaMask, if you already have a wallet set up, you'd be importing that secret key or that seed phrase into MetaMask. However, when let's say that you've never had a crypto wallet or something like that, when it creates that wallet for you, it's going to provision an address that looks like this. And then it's also going to create a private key or that secret phrase that you'd be able to use to authenticate the account. But I do also just want to say that, just a word of caution, there are a lot of like scams that are out there, and you just want to be cognizant that if anyone ever asks you for your seed phrase or your private key, they're specifically talking about this other type of key, and you never want to give that out to anyone. Of course, if you were expecting someone to send you a transaction, you would be giving them your address. And I'll show you exactly what this means, but you would never, ever, ever, and I really can't emphasize this enough, you would never, ever, ever want to give that private key to anyone under any circumstances, because that's, if they have access to that secret phrase or that private key, that's again how they're going to get access to your wallet. So I'll give you just an example of what this looks like. So I have MetaMask in my browser. I am on the Rinkeby testnet. There are a ton of different networks that are a part of just how you interact with the blockchain. There is the mainnet, which is the core network infrastructure of Ethereum, but then they also have test networks that you can use. So there's like Coven, there's Ropsten, there's Rinkeby, which is the main one. There's also Goleri, and Rinkeby is sort of the main de facto testnet, but there also are other ones if you're interested in exploring those as well. But I am on the Rinkeby testnet, and I have 7.68 ETH. However, that's not real Ethereum. Those are test ethers that I was using. So this is a dev account that I have, and I just use this for just for different like dApps or just interacting with different protocols sometimes. And you can create, an unlimited number of MetaMask wallets that you would want, but I'm specifically in my dev one. So this address is that public key. So if I wanted to interact with this and I wanted someone to send me test ether, I would send them this specific thing. MetaMask makes it so easy where you can just click this copy and it'll copy and paste this to your clipboard. Then you could like paste that into an application or, some sort of protocol. But just to be clear, this is that public key, not the private key. The private key is what you would click on this, and then you'd go into account details, and then you would be able to, you'd have to log into MetaMask, and then you'd be able to get your private key C phrase. But I'm not going to show that, obviously, because then I would be giving you access to this wallet. So definitely want to sort of emphasize those security measures just so that you can, stay safe on the web. But of course, do your own research and also make sure that you are implementing best practices as the space is rapidly evolving. You just want to make sure that you're up on the security protections that are going to help keep you safe and also allow you to build really cool things on the web in Web3. So specifically in this address, what's really cool is I have this identity. This is my 0xB48. I think I told you before, so I also have a .eth domain name. So what's cool is that if you had a .eth NFT, what I'd be able to do in that application is pair this specific address, for example, with, let's say that I had like dev1.eth. So what I'd be able to do is buy dev1.eth online. I'd be able to pair this seed phrase, and then I'd be able to then pin it. So let's say, obviously, this is a huge amount of characters, something that looks like this. This is really hard to remember, and of course, there could be errors, there could be issues, but if you had just, dev1.eth, that's a lot easier than a whole string phrase like this. So that's one of just the benefits of how NFTs or layer 2 solutions can help to optimize things on the blockchain, just as an example. But in this wallet, I see that I have 7.68 ETH, and I also have, it looks like I was working on a coin, and I remember when I made this coin. So I built the coin with a different wallet, and then I had sent myself practice coins. That's what PC stands for. So I sent myself 20 practice coins, and then I sent those back to the previous, the creator of the protocol or the contract. So that's why it says 0, but I did add this token to my wallet. So you're able to actually see that I sent it to a different wallet. And that's where it says send. So that's where everything is immutable on the blockchain. And that's where you're able to have your wallet interacting with the blockchain network. And just to give you a little bit of context as to what these wallets could look like, MetaMask is the one that I just showed you above, but there's also Coinbase, there's also Opera, there's Huobi, there's just a ton of different ones. There's Engine, Trust Wallet. For hardware, these are software mobile wallets, but if you wanted a hardware wallet, there's Ledger, there's Trezor, Exodus, there's a ton of different ones. And then there's different ones like Portis, there's Fortmatic, there's Mist. There specifically is one called Taurus, and that is for sort of email login. So you'll be able to use an email address with your crypto account as well. Also Magic Link, they are creating a lot of Web3 infrastructure right now. So you're able to log in just with your email, and then you're able to then provision, that secret key and that public key as well associated with a crypto wallet. There's also my Ether wallet. There's just a ton of different wallets out there, but these are some of the main ones. And of course, definitely do your own research and find the best wallet that works for you, or the series of wallets that work for you. Sometimes it's kind of a personal preference. Some people like Gmail, some people like AOL or Yahoo email. Some people, like more, secure emails, and maybe they like Outlook. So there's just tons of different options that are available out there. But yeah, just make sure that you're kind of doing your own research and that you experiment a little bit, because sometimes you might like certain wallets over certain other ones based upon certain, characteristics that you find out. So you'll only get that by exploration and trying things out. So we were just diving into what a MetaMask wallet looks like. And an important thing also just with an address is understanding that that public key, that address, is your email address in a sense. And that allows you to send and receive information from people, from other holders of crypto, from dApps, so these are decentralized applications, from other networks, and other decentralized systems, and also protocols or those other systems that are built on top of mainnets or blockchain technologies. Now, let's say that I wanted to send you, 1 ETH or maybe half an ETH or maybe a quarter of an ETH. So I'm going to ask you for your address. Now, there's going to be different wallet addresses for different types of blockchain networks. So there might be a Bitcoin Core address that would be different than the Ethereum address. And with the MetaMask address, that is a Ethereum-based address. So anything that interacts with Ethereum or is Ethereum compatible or EVM compatible would be able to receive or be able to use this address to then be able to send things. So Polygon, for example, is an example of something that interacts with the Ethereum blockchain. Also, Chainlink is an example of that too. So Bitcoin Core is very different. So if you tried to send Bitcoin to that address, it won't work because it's not going to be able to accept, those systems aren't interoperable. You would need some sort of bridge to be able to connect them together. Also with Litecoin, that is a different payment network as well. So you just want to think about this. Or Avalanche, that is a layer 1 solution that is different than Ethereum. So you just want to think about how when you use a wallet, you just want to make sure that if you're sending or receiving something, you just want to make sure that you're sending it to the right network as well. Kind of just similarly, like if you were trying to send someone a Facebook message, you couldn't send them a Facebook message with MySpace. You would maybe need some sort of like integration between the two, but other than that, that Facebook message is not going to reach MySpace. MySpace is not going to reach Facebook because they're not directly connected together. So just an example of this. So Chainlink, that is the coin or the token that powers oracles. And this is an ERC677 token. This is an extension off of the ERC20 token. So again, if you remember from my PopFam workshop, I went through how to create your own ERC20 token, but specifically Chainlink is a specific subset of an ERC20 token. So if you have an address, such as MetaMask, you could then receive a link as well as other ERC20 tokens. So, and it just so you know, sort of NFTs, if you've been hearing about those in the news, those are typically a 721 token standard, but there's also is 1155, which is like a similar type of token. And you can also accept these into your crypto wallet as well. And I want to actually show this to you. So when we have a faucet, there's different faucets for requesting test ether or fake ETH to be able to use on a test network. So what we're going to do is I'm going to just show you just how this would work. So when I get my wallet all set up here, so how I got this is I requested testnet ETH, and this is by Chainlink. So I'm going to switch this to the Rinkeby testnet. I'm going to put in my address, which is here. I'm going to put that in. I'm going to paste that. Now the request type, I'm requesting 10 link or Chainlink tokens and 0.1 test ETH. So we're just going to make sure that we track what this is. So I have 7.6. So if this works, it should be 7.7. So I'm going to say that I am not a robot because I'm not a robot. I'm going to then say send request. So now what it's going to do is it's going to wait for this confirmation. It's already been initiated. It's going to ping this faucet to say, okay, I want to send 10 link tokens and 0.1 test ETH to that address that I had just put into the form right there. We're going to wait a few seconds for it to confirm. And it looked like it just was requested successfully. So it says, congratulations, I have 10 testnet link and 0.1 test ETH added to my account. So let us see. And if you see that, it was 7.6 before, and now it's 7.7. So this just happened in mere seconds, and value was able to be sent from one account to another account. In the next module, we're going to be going through actually how we can validate this and make sure that this is correct. So stay tuned for the next lesson, and we're going to go through actually how to verify that this actually happened. So in the last module, we received a 10 testnet link tokens, so 10 Chainlink tokens, and then we received 0.1 testnet ETH or Ether tokens. So this was sent to our dev account, and that's how we were able to find out that this increased by 0.1. So we know that we at least got ETH, right? right? So now when we think about the Ethereum blockchain, just think of the blockchain as a public database. Now there's really two types or flavors of blockchain. There's public blockchains and then there's private permissioned blockchains. Specifically with public, those are chains like Ethereum, Binance Smart Chain, Avalanche, Polygon. There's different types of networks out there. Bitcoin Core is another example, Litecoin. These are all public. They all are verifiable. You're all able to see all the transactions. Anyone in the world would be able to, with the right scanning tool or the right searching website, to be able to then go through all of those transactions. There is also a type of blockchain called distributed ledger technology, or DLT, that is also just called private blockchain. And two examples of that specifically are Hyperledger Fabric and Corda. They create, there are DLT solutions where, let's say you wanted to have a immutable database, but you didn't want it to be publicly searchable, but only searchable to a select grouping of people. That specifically might be helpful for sort of like more finance or more like supply chain or logistics, or any sort of company that really needs to have private secure data. That's where a private blockchain might be really handy. For public, of course, finance can also apply here, where if you are sending transactions and you want to be able to verify them, or maybe you're a nonprofit and you want to be tracking your donations, you might want to be doing this in a transparent and public way. So that's where blockchain could be really helpful and advantageous for your use case. So we're specifically in this mini-series going to be focusing on Ethereum and Solidity, but it's also just good to think of other blockchains as well as you think about these things. And in the same way that you might be logging into Firebase or AWS or MongoDB or Azure or any of these other, or Supabase or any of these other sort of cloud-based databases, data is sent to their servers and they store it in a centralized way. But in blockchain, the data is pushed literally onto a public ledger, which is a public database. So it's public, readable and verifiable. Just something also to note is that reads to this public database are free, but whenever you write something to this blockchain, that is what will incur a cost through gas. Gas is the mining fee that is paid to make mutations on top of that data. So if you think of like a cloud database, right, you have the reads and writes, right? So in a public blockchain, for example, you're going to have that write, but you're going to use gas to pay to write onto that blockchain. And that's what helps to encrypt and store. And there's different consensus mechanisms, which are just basically ways of how you verify and validate data. So specifically for Ethereum, right now it is a proof of work consensus mechanism. It's going to be moving to a proof of stake mechanism with ETH 2.0. But specifically with proof of work, the sort of the nodes that make up the network, nodes are just a series of computers. So these computers are sort of trying to outcompete each other to hash that data onto the public blockchain. And then the one that actually ends up doing that is the one that gets rewarded with cryptocurrency. So the gas is that incentivization mechanism to get these nodes to be trying to outcompete each other to hash the data faster. And whichever computer or node hashes that data gets rewarded with that gas cost. So that's what you end up paying basically for someone to write the data for you. But it's not really someone, it's a computer or a computer network. So yeah, so just if we wanted to actually check the blockchain, we're going to actually, and just sort of when you think about this type of things, right? So I have this Chrome extension. I know that I received something because this was 7.6 before and now it's 7.7. So there is a computer science conundrum called the Byzantine generals problem. And what the Byzantine generals problem basically says, there's sort of a whole story of Byzantine Empire. You have a castle and there's you have your soldiers around the fortress. And let's say that there's an enemy that is approaching, or they're encroaching on the kingdom. Now, they could potentially pay off a soldier. They could potentially bribe someone, right? They could potentially, get rid of a soldier, and then that's how they could, invade the kingdom. So there's a lot of things that could happen. It involves a lot of trust. You have to trust that the soldiers are going to be reliable, that they're not going to lie, that they're not going to be able to be taken advantage of. They're going to be true to keeping your kingdom secure as long as they're able to stay there. But that involves a lot of trust. And of course, as we know throughout history, there's humans that can fall to error. So one of the things that's really powerful about blockchain is that it sort of dismantles this Byzantine generals problem, where I see that in the Chrome extension, this number increased, but how do I really know that this number increased and it's not just telling me? So when you ever have a cloud-based database or a private, database that's stored in a server, you have to trust that that data is true. Not only that it's not non-immutable, as in like someone didn't go into the backend and change your data, because if you're a database manager, you can totally do that, which you shouldn't. Obviously, if you have your users and they trust you, you should not be changing their data, but you could theoretically have someone in the backend change your data or, mutate the database in some way and change certain things. But blockchain is different because it's not, human run. It is machine run. So that involves a trustless type of architecture where instead of you needing to rely on a person, you rely on the machine, and the machine is the one that holds true to things that are happening. So I want to be able to track to see that this actually happened. So what we're going to do is, for Ethereum, there is a tool called Etherscan. And it says it right here. It says it allows you to explore and search the Ethereum blockchain for transactions, addresses, and things on the blockchain. So we're going to go here. Now, this is what it looks like. It's just a searchable database, and you're able to see the latest transactions. You can also see the latest blocks that were hashed. You're also able to see the price of Ether. You're also able to see transactions, difficulty, hash rate. You can sort of see a fun little graph here, and then also the market cap of Ethereum, and that is $355 billion, which is quite a lot of money. That's on this chain. So that's the market cap of Ethereum as of right now. So pretty cool. So we have all this information, right? So now let's try to go and check this out. Now, something that you might already know about, or maybe you don't necessarily know about this yet, but I did this with the Rinkeby network. You can see this here. It's the Ethereum Rinkeby. So you have different options for Etherscan. This is specifically for mainnet, but we're going to just change this quickly to Rinkeby.etherscan.io. And that's how we're going to be able to now see the Rinkeby version of Etherscan. Just copy our address here. All right. So I was able to search through the address, and this is all the information that just popped up. So I just received in 0.1 ETH, and that was this transaction. So actually, let us pull this up. Now let's see if this actually matches up with this. Oh, right. So that's it was this one. So we're actually calling from this one. This is different actually, because this is a link. So if we wanted to actually check out this transaction hash, yeah. So we're going to have to go to the Rinkeby with this specific address, and then that's how that comes up. So I'm able to see that this is a token that's non-Ethereum, but there is some sort of value that's associated with it. And also with this is that 0.1 ETH that we were talking about before. So that's how you're able to then see that this, and you see this also here with 0.1 ETH right here, right? And this is Chainlink tokens. So that's where those are coming from. And if we wanted to actually import this, you'd be able to copy this contract and then import that into your wallet in case you wanted to actually see that. So that's a pretty cool aspect of the blockchain, because you're able to then just see very directly, and these are hyperlinked as well, so you're able to see them. You're able to then see all of these things that are happening on the blockchain. So it's not just trusting a wallet extension, but also being able to know that this did happen because it's on the public blockchain. And that, again, sort of goes away from the Byzantine generals problem and is a solution for that, because you don't have to trust your Chrome extension. You don't have to trust, someone telling you that this happened. You're able to just go and actually, see that I did actually get 0.1 ETH from this contract address to my personal address. And you're able to even see that this is, B48. So this is that address, which is pretty cool. And this, of course, happened a little while ago, but I'm able to even see the number of blocks minted since this transaction, see that it was a success, also see the transaction hash, and those are the same as what numbers come up here. So just a pretty cool way to see how you're able to scan information on the blockchain and know that certain things are happening in real time and as they have happened as well. So as we get further and further into this mini series, of course, we're now sort of building up the core skills that we're gaining, and then we're going to be going to the more technical side and actually building out our first dApp. So, of course, what would be a technical training if we didn't actually talk about testing? Testing is super important, especially with blockchain technologies, because when we're dealing with money, we of course want to make sure that we're not sending money into the void or we're making mistakes and costing ourselves or our users, time, money, frustration. We want to avoid all of that. So one of the best ways to actually go about doing this is using a system like Truffle or Hardhat that are environments for us to test a local blockchain. Now, when you, of course, and we talked about this earlier, reads are free for the blockchain, and that's why we're able to view on Etherscan. But if we wanted to write to the blockchain, that's what's going to cost gas. And you actually see this here, where if we go on this transaction, there is that transaction fee. So of course, this is not, this is less than a penny. This is not a lot of money. But if we're sending a huge contract and we're writing a smart contract onto the blockchain, that can be expensive. If we're writing it several times, if users are interacting with that smart contract, that's going to be costly potentially. And not necessarily costly, but when you think about, and I was actually on a call just talking about text messages. So if you have a text messaging service, it might be, $1 every, 1,000 text messages. But if you have a lot of global users using your application every day and logging in or getting notifications, that is going to run up a pretty significant bill as more and more people are sending more and more text messages and more users that get added to the platform, and then they need that specific service. So that's where anytime you're dealing with money, you just want to make sure that you're testing and optimizing and making sure that you're not going to be running into hidden costs, that you understand how much it costs to deploy something. You understand really what you're going to be doing and how your users will be interacting with your system. Especially as you write contracts to the blockchain, you want to make sure that you're setting up your users and your network for success. So 2 ways in which we can do this is Truffle, which we will be using in this mini series, as well as Hardhat. Hardhat we won't be going into, but it is also a great testing environment. So with Truffle, as they describe on their website, it's your own personal blockchain for Ethereum development, and you can also use it to deploy contracts, develop apps, and also run your tests. It will provision 10 accounts for you to use, and then also you're able to then interact with those and load those into MetaMask, and then use those into the browser, for example. Truffle also has a GUI or a graphical user interface called Ganache that creates this environment for you. Instead of, if you didn't want to work from the terminal, you could then work from Ganache GUI. So that's also a part of Truffle Suite. And also I'll pull this up just so that you can see the website. But it looks like this. So these are, they sort of brand itself as like Suite tools for smart contracts, but they have a suite of tools and solutions around Solidity. So I'll just give a little bit of a scroll here. Ganache, this is what I was talking about earlier, which is a one-click blockchain. They also have Drizzle, which is fresh chain data for front ends. These are some case studies and companies that they work with, and they do a lot of open source work as well. So that's about Truffle. And then Hardhat is a similar flavor of testing. It is your own personal Ethereum development network, and you can compile smart contracts with it and run them on a development network as well. And instead of provisioning 10 accounts, it provides 20. So in case you're working with a lot of accounts, Hardhat might be better out of the gate for you. And this is what Hardhat looks like. They sort of brand themselves as the flexible, extensible, fast Ethereum development environment for professionals. And this is just a little bit, I'll do a scroll of their website just so that you can see. And here are some of the teams and companies building with them. And yeah, that's a little bit about Hardhat. So just going back to this. So again, we're going to be using Truffle in this mini series, but of course, feel free to experiment with both and find how you might be liking one over the other. Truffle allows for a lot of customizations, and I'm more used to it, so I like that type of development environment. But Hardhat also is really good. It's sometimes it's a little bit faster if you wanted to just spin up your Hardhat instance and then start working from it. But both are sort of just different flavors. It depends on what you're looking for and how that can help your dApp development in your overall goals as a blockchain engineer and developer. We've learned a lot about blockchain so far, and a lot of the foundationals are going to be really helpful as we frame up how our dApp actually works. So I'm just going to give a little bit of an intro into what the dApp looks like. I'm going to also give a demo of the platform running in the browser, and then we are going to then start building it, which is going to be the most exciting part, hopefully, of this mini series for you all. So we are going to be using ReactJS as our front end for our application. You could use any sort of front-end framework that you wish, but React, JavaScript, and even Next now, those are the ones that are really taking off, and there's a lot of tutorials, documentation, videos, information online around the JavaScript framework. And as you see with Truffle, a lot of those files are written in JavaScript, so it's sort of a JavaScript-y environment. So hopefully if you're familiar with React and Next, that'll be easy for you to understand what's going on, but I'll try to go through and unpack the front end and how everything works as we build this together. We also are going to be using something called the Web3 JS API, which is how we're going to be able to connect to a blockchain instance, which we will configure with Truffle. We also are going to be using Truffle as our local blockchain environment. And then we're also going to be simulating this local blockchain network, which you'll see running in our terminal window. We're also going to be using MetaMask as our wallet and to simulate users logging into the application. And even before this, we're going to be using Remix as a testing tool for our smart contract. Remix is very powerful for Solidity, and it also helps us test individual contracts really before we need to be doing anything in VS Code. So it's just a really great graphical user interface or a GUI to be testing the development of smart contracts. So I'm going to show you this application. We're going to do npm run start, and I'm going to boot up the application. It's going to then start running the development server. It's then going to open up in another browser momentarily. All right, so as soon as we have our app loaded up, what we're going to do, and this is when we run npm start or yarn start, that's how we're going to get our React app running. I initialized a Truffle instance, and I did npx Truffle develop, and then that's what I was able to get my instance. That's how I get my 10 accounts for the instance, and also this local blockchain network running. Then when that's all set, I run this command called truffle migrate reset and then compile all. That's going to then compile my smart contract, which is change state input, which is on the right. I'm then going to run the migrations file, which will then migrate this onto the network. And then when it's compiled successfully, I'll see something like this in the output. And then it'll start the migration onto my network, which is develop. It's going to do the initial migration. And then it'll deploy the contract, which will replace the state change input, which is my smart contract. I'm going to get a contract address here, and I'm going to get an account that it's deployed to here. And then it'll cost some ETH, and then it'll be deployed. So what's really cool about this is our application. So right now it's checking if a Web3 instance is running. That's why the connection successful is here. I see that we have our app running. And what is kind of the cool thing about this is with Truffle, I have an account, and actually I ran a transaction prior to this, so that's why it's down a little bit. But you're provisioned with 100 test ETH to run your network and run your application on a node. So what we're going to do is I'm going to get the state of contract, and this is 0. So what we're going to then do is we're going to change this number. Let's say that we wanted to change it to 55. So I'm going to set the state of our network. This is now going to run MetaMask. MetaMask is going to see this as a transaction. I'm going to confirm this. And if it's successful, it looks like it is here. There's a transaction hash. There is a block number, transaction index. And then you can really drill down into all of this information about what's happening on the blockchain or on our local network. But now when I get the state, it's 55. So this is actually something that's really fascinating with blockchain is I'm able to then log into other wallet accounts on this network. And this network is the port 9545 on my Truffle instance. Any account that I was logged into, as long as it's connected to this network, it's going to be able to get the state of this number. So I wrote the contract in a way where it's a public function, and anyone that has access to this function or this clickable function is then able to set the state of this number. And you could use, ETH or gas to then write this onto the blockchain. So then if I get state, I can get this as many times as I want. It's not incurring any costs. But as soon as I change it to, let's say 65, set state, this is going to now run another transaction. Going to confirm it, and then it'll run another transaction. Now when we get the state again, it's 65. So what's very fascinating about this too is if I wanted to run this on my network, I can actually see these transactions happening in real time. So this is 5:30 and it's 5:30 right now. So technically 5:31, but you're able to see this network that's listening to all of these transactions happening in real time. So this is simulating this blockchain network. And if we wait a little bit, it'll update with different information. And as I do certain things, if I get the state, ETH block number, so that just added something a few milliseconds ago. When I write something, let's say 75, and actually I'm going to put this up just so that you can see it happening at the same time. So you'll see it's getting balance, it's getting code, it's getting transaction count. When we run this transaction and confirm it, it's now going to run a whole bunch of stuff. And that's what the blockchain looks like. And then when I say get state, it's already updated again. So this is an example of how blockchain is able to rapidly transform data, and I can't go into the database and change this. This is something that's immutable. I ran a transaction that changed the state, but I can't now go into the database and change this information. That's what immutable means. So this is all publicly written to the blockchain, but in this case, it's our local blockchain network. But it's written specifically onto the public database. So no one could really go and set this unless they had access. The first thing that we're going to do when we want to create a dApp, at least in my opinion, is we want to architect a little bit of what we are going to do. So I think one of the things that I just want to have us draw up, and we're going to use ScreenBrush to do this. So something that I'm just going to have us do is I want us to really think about what's going to be happening. So there's going to be this application, right? There's going to be the blockchain here. Right, so this is our blockchain block. This is going to be our dApp. So this is, of course, with React. So this is going to say ReactJS. The bridge between this is going to be Web3.js. We are initializing our blockchain instance with Truffle. And that's pretty much going to be it. We will be using styled components. But that's just for a little bit of styling and just to help with our overall structure. And we'll also be using MetaMask as our wallet to connect to this. And Truffle will also be using some tooling with Ganache, but mainly the thing that we're focused on right now is with Truffle. But it does use a little bit of tooling from Ganache. So when we think about what we're going to be doing, really, there's sort of two parts. There's the set, and then there's the get. So this is going to be writing a variable that we're going to call v. Now, when we write to this, that's where it's going to cost ETH. So this is the symbol for ETH. So that's going to cost money, and maybe it would just be easier to think about it with like a $sign or something like that. So this is going to cost money when we write to the blockchain, right? And this is a write if we're changing this value. However, if we're getting it, this is free. So again, those reads, but this is a read, and the other is a write. So just sort of thinking about, there's really just two functions here. There's a set function, a setter, and then a getter. So the set of the variable onto the blockchain, and then a get coming from the blockchain to the front end. So those are really going to be the two inputs that we have. Maybe we also kind of want to maybe track like the state of the chain. So you'll sort of see before, but there's like that little block of changing state of the blockchain if there's a Web3 instance. So that's pretty much going to be our system architecture. There's really two things that we need to focus on, and then this is the system. So again, it's React, there's Truffle, Ganache, Web3 instance, Web3JS instance, and MetaMask. And yeah, so once we sort of get our bearings of what we're building, this will help to make so much more sense as we actually go and start to build out the system. So now that we have our system architecture and we know exactly what we want to go out and build, we're going to go to a website called remix.ethereum.org. And you'll see this at the top. It's just https://remix.ethereum.org. This is an amazing IDE for coding in Solidity. What's really great about it is it configures this environment where we'd be able to test our smart contracts, actually run, compile them, and then deploy them and in a test environment and see actually how they would work. So what we're going to do is we're going to go into our contracts folder. We're going to, and this is just on the home page, we're going to do create a contract, or actually in here, we're going to put it there. We're just going to call it state, call it change state input dot sol. All right. So this is, and .sol is in Solidity. So if you're coding with JavaScript, you put like, JS or, TypeScript with JavaScript, maybe it's like TSX, but this is .sol for Solidity. And we are going to, I'm going to make this a little bit bigger just so that we can see. Okay, cool. So what we're going to do is you declare the license from the start. So spdx license, and then we're going to do identifier MIT. And then every smart contract always needs a pragma statement. This just defines which version of Solidity we are going to be coding in. So we're going to say pragma solidity. We're going to say greater than 0.4.26, but less than 9.0. So then every type of contract is just a type of function. So we're going to say contract, we're going to say change state input, and we're going to put this and the brackets. And that's pretty much the container for this. Now, what we want to do is let's kind of map out exactly what we need to do. So there needs to be some sort of variable. There needs to be, and obviously we defined this before, but there needs to be some sort of function where we are able to write to the blockchain. So maybe like a setter function to change variable on chain. And then function getter to return variable from chain. So those are sort of just the main inputs. And this is actually really important just to sort of get this structure in place for how we're actually going to be going out and building this. So when we declare variables, there's many different types of variables. In Solidity, it's a strongly typed language, so you need to make sure that you define everything correctly. What we're going to be doing is, for our state input, this is sort of, we're changing the state input, but there's going to be some sort of integer that's going to be a state input. It's a number. And the way in which you declare an unsigned integer is with unit 256. So unit 256. And we're going to call it state input. Now, in terms of the function that's actually going to be working with the state input variable, what we're going to do is we're going to declare a function. We're going to set the input of that function to be unit 256. And we're going to then call it a public function. And it's going to do something. So really, what we're going to need to do is we're setting a variable, but what's the variable we're going to set? So in terms of the state input, we're going to have this called above, and we're going to make this equal to v. Now we're going to make this set equal to v. So when we set the unit 256 with v, the state input is v. So that's what we're doing. So anytime that we're setting this variable on chain, we're going to be writing to this v variable, and that's going to update the state input. Now, the next function, we're going to do another function. This is going to be a get. We're going to then make it public. And something that we're going to do is we're going to allow us to be able to view it. So we're going to return this u256. And we're going to then put some brackets here. And we're going to say return state input. So that's what's going to allow us to basically return that state input once we set it. So again, setting the variable, we set the variable equal to v, and we already know that's a 256 unsigned integer. And this is a public function, which means that anyone that's able to call this function will be able to set it. We don't have any modifiers. We're not going to get into modifiers on this module, but modifiers would be a way to modify who specifically can modify something. So maybe the person who deployed the contract is able to set the number, but only people that have access can view it. So something like that. And then, of course, this is the get function to return the variable from the chain. We're just getting it with public view returns of the unit 256, and it returns the state input. So that's pretty much it. Now let us see actually if this will work. So what we're going to do is we're going to go to the bottom here. We're going to go to the compiler. Now we are in Solidity. We are already here. What we're going to do is we're going to, and that's just if you wanted to like compile it, you can, I have it on auto compile, but that's just how you would be able to check if it's compiling. So now we're in JavaScript. This is what we're going to be. So this is what it creates for us. It creates these accounts with 100 ETH in each of them. Now, what's really great is if you actually refresh this page, these will refill to 100. So just if you ever need to refresh your page, but these will be different accounts. So just make sure that, if you are deploying a contract, just you're cognizant of that. So now what we're going to do is we already know that we want to, input this. It's already capturing from the IDE. We're going to deploy this contract. Now, when we deploy, we're able to see that this is running because it's transacting, it's going through. There is a whole bunch of information about the status, the transaction hash, to, from, all that type of good stuff. But now that we have deployed our contract, there is something here that we can see. So when we deployed our contract, we had set these functions. So these are now functions that we can receive. So when we press get, it's already set to 0. So that's because there hasn't been any data sent to it yet. So let's say that we wanted to set this to 5. So we're going to set this to 5. It looks like it went through. There was an execution and it said success, and the transaction was mined, which is true. There was gas that was sent, and you see unit 256 V is changed to 5 in the decoded input. So now let's test and see if we did get. All right, so that worked, and we're able to now see that we can get the 5 that we just set. Let's set up 15. We'll set 15. Transaction went through. Get. You see that in Remix, it's changing to 15. Now, you might also notice that this is going down a little bit. So that's because we're writing to the blockchain, and that's what will incur costs. One of the very cool aspects of blockchain is when you deploy something to a given network, all of the people that are a part of that network are able to interact with it if they have those privileges. So this is a completely different account. Now, let's see if we're able to, and I'll just delete this for a second. So let's see if we're able to actually get this contract, right? So we're calling on that deployed contract address. And it knows that, first of all, it was 0 when we started because we hadn't called anything yet, but it's calling what was set on the blockchain, which was 15. So now if we wanted to actually change this, and let's say we wanted to change it to 51 instead. So I'm able to log into this completely different account. Now I've lost some ETH because I just deployed something. Now let's get it. So now it's 51. Now let's go back to the previous account and let's see if that was actually able to return that. So delete that. So if we get it, look at that. So 0 to 51, and that's the decoded output. So what's really fascinating about blockchain is all of these accounts that are a part of this network are able to interact with the smart contract in the same way because we have these public functions and public views to be able to view this state input and also write to the state input. But yeah, so that's pretty much it. So our smart contract works, which is fantastic. And now we're actually going to start building our dApp around it. And of course, you might be wanting to optimize these smart contracts further. So that's where Remix is a really great, low stakes environment to be able to build really fast and also debug your code. It gets a little bit more complicated if you're deploying multiple contracts and you need to be running certain functions and that type of stuff. So sometimes VS Code and running it from your browser might be easier, but at least to test the basic structures of smart contracts, this is going to be key for us. So yeah, great job on this, and we will go to the next module. All right, so in the last module, we wrote our smart contract in Solidity in the Remix IDE. Now, to give a little bit of context to what Solidity is and what it's all about, it is the most widely used and recognized smart contract programming language globally. It is the native programming language of the Ethereum blockchain and other blockchains that are EVM compatible. So what's EVM? So EVM is just the Ethereum virtual machine. It's similar to how you might have technologies that could interact with a specific type of network or a specific type of framework. The EVM, or just Ethereum in general, is powered by Solidity. And there's other blockchains that are EVM compatible as well, including Polygon, Avalanche, and a lot of other very popular blockchains networks. Now, smart contracts are really just public functions put on the blockchain. And of course, from the blockchain, we know that it is just a public database that you can write and read to, or write to and read from. These smart contracts are just public functions that are put onto the blockchain. Anyone can look them up. Anyone can search for them. Anyone can see them. That's the whole point of you have this trustless environment where people can actually validate and verify information in real time. So, example of what I typically talk about with something like this is these are similar to like Cloud or Lambda functions. You have some code that's stored somewhere, and then you use an API to do CRUD functions. So, create, update, delete, those types of specific functions or reading. You're able to do reads and writes to that function. However, Lambda functions and Cloud functions are shielded, meaning that they're private and they're only viewable by the person who administers that backend. So what's different is with blockchain, everyone is able to see those functions. Everyone is able to see what it does. And this actually helps to improve transparency because you're able to actually know what the function is going to do. You could see, is it a payable function? You could see, is it a minting function for an NFT? You could see if it's just a get, or maybe it's a read on a wallet or something like that. You'd be able to see all of that information in real time and validate a function to authorize it or not based upon what you're able to see. So it's just really a good way to think of how public functions are really just smart contracts, and smart contracts are really just public functions. So it just creates a level of transparency and openness that currently hasn't been seen in technology thus far. And it creates this trustless environment where you don't need to trust third parties because you can review everything yourself. And also machines are validating the information directly. So when you're building a decentralized application for the first time, there is a little bit of a setup that's involved to help you get started. So I wanted to list out a number of the steps that we're going to take together to build our state change dApp and sort of walk you through the technologies that we're going to be building and then also the ones that we're going to be installing as well. So first of all, definitely 100% need NPM and Node.js installed globally. So you can just go to the nodejs.org website and it looks like this. And you're just going to be installing a version of Node.js that will live on your computer. And that's how you're going to be able to work with the Node package manager to install dependencies, run the development server with React or Next or any of the front-end frameworks that you end up using. I have the LTS version, and this is the one that's recommended for most people just because it's the one that's most compatible with long-term support. So yeah, just want to make sure that you're choosing the one that is the one that's going to have. So the version of this might change, but this is the version that that I installed, which was the LTS version. So once you install Node, you need version 8 or higher. NPM comes preloaded with Node.js, so that's the Node package manager. And if you've ever installed packages in React or Next or any front-end framework, that's how you're able to actually install those from npm.js. So that's how we'll do that. Now, what we're going to be doing is we're going to be bootstrapping the create React app template. So you're going to do npx create React app and then the name of our project, which is change state dApp. And this is a React.js project using the CRA template. Now, we're going to be installing the Truffle framework onto our computer globally. Now, this is a global CLI that's used for building and testing the blockchain smart contracts locally, as well as allowing us to work with that blockchain local instance that we create. And of course, this is a local sort of a fake Ethereum environment, but it's to simulate what it would look like to actually be building on a chain. So we'll be able to just use npm install g truffle, and then that's what's here. So when you go to trufflesuite.com/doc/truffle/quickstart.html, that's what's going to walk you through all of these steps. So I'll actually zoom in a little bit, but when you do npm install g truffle, this is where they already have said that you want to make sure that you have Node and npm. When you create a project, that's how you're going to actually be able to use Truffle to do certain things. And there also is something that I have found where when you install Truffle, sometimes you do need to install the Ganache CLI. So I'm just going to show you exactly where that is. So on the quick start, there is a way to migrate with Ganache, and they have a whole bunch of tutorials on basically how to do this. But I will show you as well where that is. So basically Ganache, it's just a way to set the network ID so that you could use a graphical user interface as opposed to the command line. And it's actually a really great way to connect to a local blockchain. It's a little bit more visual and sometimes can help if you're really trying to see logs, blocks being hashed, contracts being written, really more visually see the balance changing in real time. So this is how you'd be able to manage it with Ganache, and this is what it would look like. But let me actually show you what this is. So if you go to github.com/trufflesuite/Ganache, if you scroll down, it'll actually tell you how to install it. So when you do npm install Ganache, that's how you're going to be able to install Ganache. But if you want to install the CLI globally, you'll just do npm install Ganache -- global. And that's how you're able to then run from the Ganache CLI. The reason I mention that is because there is documentation out to talk about how you just need Truffle, but I have found, at least in the early beginnings when I started developing, that you did need the Ganache CLI and the Truffle CLI because sometimes they would work together. But yeah, just throwing that out there, that if you ever are having issues with Truffle, you might need to install Ganache. You might need to install the actual graphical user interface, which is an application, as well as the CLI. So yeah, just to give a little bit of context there. And this is all on the documentation, which is here. And what we then do is when we've already installed the Truffle or the create React app template, we're going to initialize Truffle for the project. This is going to create a contracts folder, a migrations folder, and a Truffle config file. Now, the contracts folder is where our smart contracts and Solidity goes. The migrations tell our smart contracts how to get compiled and where to get compiled and deployed from. And then the config file is just a configuration file for the Truffle environment that we create for that Truffle instance. We're going to be installing some dependencies. So we're going to be, first of all, installing styled components. That is my favorite front-end framework, or just a styling framework for building in React or Next. Web3, that's going to allow us to connect to the blockchain smart contracts that we deploy through that API middleware layer. React Loader Spinner, this is actually how I'm sort of using this to check the instance of Web3. We're going to be using that. I like that as it's kind of like a nice little visual there. And then the Web3 React Core, this is the React toolkit with hooks that we can listen to as well. So once we install those, we're going to be writing basically two smart contracts. One that's for our actual contract for state tracking. And then the second one is the migration that we'll use to compile and deploy to our instance of Truffle. So this is going to be our migrations file. This is going to be our state change file. And then when we create two migration files, this goes into the migrations folder. The first is for the initial migration and the second is for the deployment. So that's a little bit of what they would look like. We're going to configure the settings for the Truffle config file. So there's a whole bunch of settings when you actually do the Truffle initialize, but we're basically going to create a network. There's going to be some sort of development environment with a host, a port, and a network ID. There's going to be compilers, but we're specifically denoting this type of Solidity. And yeah, so then we're basically going to be using, and you might actually, when you install Truffle, you might not need to say npx. I just have Truffle behind npx, so I have to say npx Truffle develop. But if you install the CLI not behind npx, then or npm, then you probably don't need to do that. But you will say Truffle develop. This will help you get the 10 wallets. You then can also run a concurrent command or terminal window that will log the events. So you could just do Truffle develop log. It'll see that you already have a Truffle instance running. So it'll just be a listener for that. And then we're going to also configure our MetaMask environment. So when we have our MetaMask wallet, we're going to need to set a local host with this specific network ID. And then when we compile our smart contracts, we're going to be migrating and compiling them onto this Truffle instance that's going to be on that network that we're then able to connect to directly. Now, we're going to also get a JS file that exports the ABI of the smart contract. This is what we're going to reference as a deployed contract with a series of metadata in JSON format. We're going to want to bring this into our application. We then are going to change the address of the variable contract address, which you'll see in the app.js file. But we're going to basically take this contract address when we deploy the contract. This contract is deployed to the first address in the Truffle wallets that are configured for us. And then there's going to be some costs that we, deploy this to the chain. And then that's what we're going to be updating our application with. All right, so we're going to get started. So I am in my folder. I'm going to then say npx create React app. We're going to call this change state dApp. So again, that's npx create React app and then change state dApp, which is the name of the project. So now it's going to bootstrap the create React app template, and this is going to load all of that information that we need for our template. So this is going to install all of the node modules and all of the information that we need in all the code files. I'm just going to fast forward ahead so you don't have to see all of the loading, but it'll finish loading in the next recording. So now that it's finished loading, it says the message at the bottom. So now we know that we are ready to start. So I'm going to say code because I have that command in my terminal. So now what we're going to do is we are going to, and I trust that. So what we're going to do is we are going to then cd into change state dApp. So if you can see my screen, I'm just changing the directory into my change state dApp. So ls, and then I am in there. So this is, we're just going to have that there. And these are our different modules and our different subfolders. So that's all well and good. And now something that we're going to do is we are going to now install our different dependencies. So we already have the Truffle version that we've already set up. So again, if you haven't already done that, make sure that you're going to be installing the the Truffle CLI, which is npm install g Truffle. And this is just for global install. You also may need to install Ganache, but that's on the GitHub here. So just again, in case you can see it, it's github.com/trufflesuite/Ganache. You may need to install this if Truffle isn't recognized on your computer. So just as a heads up there. But other than that, if you need to install Ganache, it's npm install Ganache -- global. So that's how you're able to get the Ganache CLI on your computer. And we should be all set after that. There is also a GUI, which if you want to check out that with Ganache, definitely a good option to check out. So yeah, so now what we're going to do is we're going to go back into our VS Code. Which is right here. And what we're going to do is we are now going to get this booted up. So we're going to do npm. And what are we going to install? Let us make sure that we have everything. So we're going to add styled components. And actually, I have this right here. See if I can do them both at the same time, which hopefully I'll be able to. So you can see. So we're going to do npm install styled components web3 React loader spinner and web3 React core. So again, styled components for the styling, web3 to connect to the local blockchain, React loader spinner. This is for a cool state management, so someone will be able to check the blockchain is running, and then the web3 React core for the toolkit with hooks. So we're going to run this, press enter, and now this is going to install those dependencies as part of our project. So we're going to wait for this to load up. And I'm actually going to, I'll pause the recording and then re-record once it's all done. Our modules are now installed into our application. So now what we're going to do is we're going to do npm start. And this is the command that's going to allow our script to run. This is actually coming from the package.json file. So something with React is it will configure all of the dependencies in a JSON file called package.json. And then in the scripts, there's a start script, and you use that with npm, which is Node Package Manager. And then that's how you get React scripts start here. So that is what is starting up, and we're going to be good. Now, something that I do think is worth noting is the newest version of React runs a lot of output related to the Webpack, and with the bundle.js, it logs a lot of the static files. Typically, you just want to get this output, but it will generate a lot of this extra code that we don't want. So something that I'm going to do is I'm going to stop the development server. I'm going to actually add in a previous version of React. So instead of 17.0, I'm going to put 16.8. For React DOM, I'm going to go down as well to a deprecated version from 17 to 16. I'm going to keep everything pretty much the same. With React scripts, I'm going to bring those down from 5 to 3. And styled components is good. Web Vitals is fine. We will want to install Truffle as well. So I'm just going to add Truffle into here. We did install Truffle globally, but we want to be able to also have it as part of the project. I'm going to then delete my node modules. And this is actually just spinning because it is still just running technically. So I'm going to save this package.json. I'm going to do npm install. And it's now going to take what I've put into the package.json file and then install all of those node module packages into our application. So just in case you ever see those specific errors with the output in the terminal when you run npm start, just make sure that you go back to a previous version of React, React DOM, and then specifically React scripts, just to make sure that you're not getting that logged output. So now that I've updated my package.json, I've installed this, and these new node modules are there. I'm going to then do npm start, and that's going to run React scripts start, and this will get rid of those errors that we were having. But they're not really errors, it's more just output from the command line, but we don't need to have that. And there might be an issue with the app.js. So what we'll do is we're going to import React from React, the top, and then that should get rid of that issue. So this is just going back to previous version, and now we get our output here, and we don't have all of that logged output. So just in case, that's a little bit of a hack in case you ever get that output and you're wondering why, it's just the new version of React. So now what we're going to do is we are going to start building our application. So when your app loads, you see the spinning logo, and that's the template. So what we're going to do specifically is we're going to cut out a lot of the styles and a lot of this filler code. So we're going to specifically take out everything from header all the way down to header. And it's going to leave just an empty div. And there's going to be just a white screen, and we're not going to have anything there. So this is all of the styles in the index.css, and this is the app.css. So this is in the app.css file. We're going to basically take all of this and copy it down because we're not going to need any of that. That's just from the previous template. But I do like to have everything centered, so we'll have that unless we want to, remove that. So now specifically what we're going to do is we're going to start actually coding this out. What I really like to do is use styled components just because I really like this framework for building. Instead of just having like a div.className, equals app, you can just have the div be its name itself. So we're going to create a little bit of organization here. So we're going to call this components. We're then going to name and call this app elements.js. Now what we're going to do is we're going to actually have this on the side, and we're going to just do this. So if you ever want to quick switch this, it's command and then B, or on HP it might be control and then B. So what we're then going to do is I'm going to have that on the right, and I'm going to have my code that I'm coding on the left. So I'm just going to pull up this here and just align this a little bit. And I'm actually going to take this down just because we don't really need that. But I will just keep this here, and I'm just going to make sure that it's compiling successfully, but I'm just going to keep it here just so that I know if it's compiling or not, but we don't need to have it taking up the entire space. So that's all well and good. So now what we're going to do is we're going to start building out this. So I already have the design of what I wanted from before, which is going to be sort of two inputs. One is the input where you set, and then one is the get, which is going to be receiving the number from the blockchain. So what we're going to do specifically is I want to build out a little bit of organization around this. So on the right, which is our app components, and again, that's going to live just in our components subfolder and then in app components. I'm going to import, and we're going to have different elements here. So we're going to say from page or dot backslash, or actually we would probably just do components. So components and then app elements. We're then going to import styled from styled components. And if anyone's wondering also just how I wrap the text, it's Alt Z, or that might be Option Z on a Mac. So once we save this, we're going to be able to import those. So we render JS objects in styled components, and then we import them as divs, or basically as components, into the file that we want them from. So I'll give you just a little bit of a quick example. So when we are going to be building this out, so we have everything around this class name app, but how would we actually make a component? So I'm going to make an input box container, and I know that I'm going to need that to be capitalized up there. I'm going to be importing this from here. I'm going to do exsc, and something that is an amazing extension is the styled components extension. So if you go to extensions, go to styled components, you're definitely going to want this, which is styled component snippets. This is absolutely amazing. And then there's also styled components, which is a recommended extension as well. But styled component snippets is absolutely amazing. If you're familiar with React snippets, where you might, if you want to do a React functional component, you write RAFCE and then enter, and then that'll get this. You do EXSC for specifically the type of objects that we're going to be rendering out here. So when I have this, I'm going to do input box con. I'm going to put that here. This is a div. Now it's going to basically be the wrapper around our whole application. So we're going to call it width. We're going to give it 100%, and height, we're going to give this 100 view height. So now we're going to do one level below. So we're going to actually have this be our box. So we're going to have input box. We're then going to import this from there. We're going to do exsc, input box. We're going to have this be a div. And we are then going to be putting in a bunch of styles. So we're going to want a background color. And I have a nice blue. You could obviously choose a different color if you'd like, but I thought this was a nice sort of calming blue. That's color white. Let's do width. Let's say that this is going to be 60% of the overall width of the screen. Let's say that we give this a height of 250 pixels. We're going to also say this is position relative to where it is on the page. And then we're going to center it. So we're going to do left 50, top 50%, transform, translate, minus 50%, minus 50%. And then in terms of border radius, we're going to give this 30 pixels. So that's just going to round out the edges and make it look not as sharp, but more rounded edges. And let us then maybe add a little bit more here. But I'm just going to first of all save this. I'm going to save this as well. And there's going to be input box is not defined. All right, because we didn't call it input, called it input box. So I'm going to save that there. And now right here, so we have this centering right in the middle of the screen, which is great. And that's going to be helpful for kind of allowing us to do a flex. So as we dynamically move this, it's being able to change in real time, which is great. So now we're going to put some things in this. So I want to put a status symbol, but I'm going to put that later. I'm going to have some titles. So we're going to have input box items in here. We're going to import this from this object. We're going to do exsc. We're going to call that. And this is specifically going to be a div. And we're going to be putting in some of the items that we're going to have for the text input and also the rendering of the state, which you'll see in a little bit. So we're going to also center this within the inside circle. So we're going to do left 50%. We're going to say top 50%. We're going to transform translate minus 50%, minus 50%. And then we're going to make this position relative to everything that's on the inside. And then in terms of the input this, we're going to then put something. So we're going to, first of all, create a title for our page. We're going to call this state change dApp. Now, we also are going to want to have a form, but I'm just going to, first of all, save this, and we show that here. Okay, great. So now that's already giving us a title, and that's already centered in there. Now, what we're going to do is we're going to create a form. We're going to say on submit, and we're going to basically have some sort of state or something like that, but which we'll get to later. So that's where on submit, we're going to have a function. It's going to go and do something. Now, in terms of the label, we're going to have a label first. We're then going to have some information about what it is. We're going to say my state. Actually, I'm going to wrap this a little bit. So my input equals something. So this is going to be sort of the input field for, we say like my input. So this is a number that we want to change. This is just the text for that. We're going to then have an input, and this input is going to have some properties. So ID equals state. We're then going to have a type. This type can only be a number because we only want to be able to set the number, and that's what we defined in our smart contract with the unit 256 integer. So it's a number, and we needed to enforce that it will be a number. We're going to give it a name, so it's going to be state input, and there's going to be some sort of value, which we'll call state, and on change, we're going to go and do something. So we're just going to leave this there for now. All right, so we're just going to put this in there for now. I just want to put null, and then what we're going to do after this, so we have label, and we're going to actually move this underneath input. We're then going to put a break. We're then going to put another input. And I'm actually going to make it capital input. Actually, let's make it lowercase input. We're going to put this down. We're then going to put some props. So this is going to be our submit input. So we're going to say submit, and then for value, we're going to say set state. And this is what's going to allow us to submit this value that we input here. So then we're going to put another break after form. So we're going to do break. We're going to put a button, and then we're going to give some properties to that button. So we're going to say that on click, something happens. So let's just say null for now. And the type is button. And then this is going to allow us to get the state of blockchain. So this is sort of the input form here, which we're going to be setting something. We then break it off, and then there's going to be a button to actually get the state as well. So that is all well and good. And then after the button, we're going to do a couple breaks. So line break, line break. We're then going to get the state of the blockchain. So we're going to say, actually for the div, we're just going to say style. And then we're going to add some styles. So we're just going to say border. We're going to say 1 pixel black. And that's enough for the styling. And then this is just going to return the value of the state. So we'll just say null for now, but we can actually just say, let's say like state returned here. So then after that, we're going to save it. And let us see what we have so far. And there might be an error where it's saying on submit. We're just going to put null. And then for input, we're going to do exsc. We're going to call it input. And then we're going to give that input some styling. And this is also, so with style components, you just say the styled input. We're then going to give it a height. So let's say this is 40 pixels. Let's say this is font size 20 point. Let's say that we have a width of 150 pixels and margin bottom 10 pixels. Then we're going to import that from here. And we're also going to call use state. Now, when we're calling certain things, so I just want to see if we're able to, oh, right, because we're not gonna have a value. So I'm just gonna put, let's put 0 for now, just because we're gonna have to change that in a second. All right, so this is what we have so far. So basically we're gonna be having an input that we're gonna set. So we could put 5, or we could put like a certain number here. And obviously like with the value, we're not able to actually set it anything, but that's why like the value is 0. We're not actually able to set it, but we would be able to put a number here. We'd be able to then press this button. It's gonna set the state to the blockchain. So it's gonna basically run on the API, ping the blockchain, check if we're able to actually run the transaction. It's gonna open up MetaMask. Then we're gonna be able to then run a transaction that sets the state. And then if we say get state, it's gonna actually return this. So we say state returned here. So obviously this is going to actually return the real value of here, but this is what we're going to be able to check. So that's great. Now let's put in some React hooks because we're going to want to actually change some of this data. All right, so we just finished building the front end of our application, but we're going to need some state to help manage some of these inputs. Specifically, we're going to be needing state for the input to track us sending data to the blockchain, and then also state in returning the value of that state that we set. So what we're going to do is we're going to use some hooks. So we're going to use state hook in two specific ways. So in the front end in app.js, I'm going to go under the function. So this is the value of React functional components is you declare the function specific of a page or a component, and then you declare the state variables at the top, and then you can call them in the return statement. So we're going to declare basically hook number 1, and that's going to be for setting state, and then we're going to do hook number 2, and that's going to be for getting state. So we declare this with const. There's going to be state and then set state. We then make that equal to 0 initially, and this maps to our smart contract. So in the Solidity pragma file, specifically if you remember from before, when we create this contract, we initially set the state input to basically like a null value, which is 0. So that's why this is just going to be 0 from the start. And then in terms of the second hook, we're going to say const. We're going to say get state and then set get state. We're going to make that equal to use state. And I'm just going to put a click to refresh, just so that it can remind people to, click to refresh and basically just get the state when it's running. And just to note, this actually won't be able to fetch anything until the blockchain Truffle instance is running, or you're connected to the blockchain. So Anyway, just so you know, so this actually wouldn't be able to return any value until, and it'll error if you try to do this if you're not running a blockchain instance, just as a heads up. So, okay, cool. So where we're going to actually put this is in our app.js file. So we're going to put that in a couple of places. So specifically, we're going to make the value of this. So instead of this being 0, we're going to make this the value of the state. So we're just going to say state here in the input, and that's what's going to make this 0, not really a 0 as an input, but a 0 as in the default value of the state by default. And then when we have our value for get state, so instead of saying state returned here, we're going to actually change this to just be get state. And that's what's going to go here. Now we're going to save this. And that's going to change the value from that. And if I refresh, that's uploading there. So now that we've added those hooks to manage our state, we're going to now want to initialize our Truffle instance. And that's what's going to be a part of our project. So in the same way that you would be declaring, an API or running a server, and then you're connecting to that server, we're going to be basically running Truffle. We're going to basically create a bunch of files in our project, and that's going to help us connect to the blockchain locally. So the way in which you do this, so once you have the Truffle CLI installed, we're going to basically run a function called npx truffle init. And that's going to initialize Truffle. So if you see in the terminal, it's just npx truffle init. And I'll just make this a little bit more zoomed out. So as soon as I press this, I'm going to press enter. And I know that I'm going to make sure that I'm in the right folder, because that will help to make sure that this specifically goes to the project. Okay, great. So you can always do, ls, which is listing, and then cd into the folder that you want to go into. And then I'm just in the root project. That's just because I'm in a folder that holds 2 subfolders. So that's why I just wanted to make sure I cd'd into that. So now that I'm in change state dApp, which is our application, I'm going to say npx truffle init, which will initialize Truffle for our project. So you'll see that here. So it says npx truffle init. Now I'm just going to keep this open just so that you can see these files being created. So I'm going to press enter. And you'll see here that init was successful. And you'll see that there was a ton of stuff that was just added. So there was specifically a contracts folder. There is a migrations folder in that. There's also a migrations subfolder with an initial migration 1 that's there. We've also added a test folder and also a Truffle config file, which is a JS file. So these are going to be the files that we're going to be depending on to manage Truffle in our project. And this is actually how we're going to be working with the state of our application, because we're going to be making calls to this blockchain instance, and we're going to want to make sure that we have a Truffle instance that's connected. So what we're going to do specifically is I want to edit the Truffle config file. So the Truffle config file is actually going to be what we're going to be using to basically make everything work correctly. So I'm going to just delete a lot of this filler code here. It's important to know the different things that you can do in Truffle, and I definitely would recommend checking it out. But for us, we're just going to kind of copy out some of these things. So we're going to first declare path. We're going to require path from the start. Then in the module exports, they do have a place under network that you can find, or you can just build it yourself, which sometimes it's a little bit easier. And sometimes, honestly, like I kind of like just being able to just kind of work from what I have. But in terms of this, so you can kind of like comment out certain elements. So I'm just going to delete that. And I'm just going to try to find compilers. Yeah, so we can delete all of this stuff. If we were actually putting it into production, you'll have multiple networks. But since we're just in development, we're just going to have that there. So I'm just going to clean this up a little bit. So we declare a network. We're declaring a development network. Now, if you are doing different networks, like if we wanted to deploy to Rinkeby, you would have like Rinkeby, and then you'd sort of have like different elements there, such as like the chain code and that type of stuff. But we don't need to worry about that right now because we're just building with the development. And under the host, it's 127.0.0.1. Under the port, I do actually change the port to be 9545. And then network ID, we just keep that to allow all. And then under the compilers, and actually we're not using Mocha for testing, but if you were using Mocha, you could have that there. But I'm just going to delete this because we're not testing with that. So under the compilers with the SLLC, we have version 4.26. So I'm just going to change that here. And then under the optimizer, we are able to add that in there. And we're just going to enable that to be true and runs 200. So that's all set. And then that should be pretty much it. We'll just delete the rest of this part here because we're not dealing with the database. And that is pretty much it with the Truffle config file. So yeah, this is just sort of important to be able to declare the right network. I'll show you in a second with MetaMask how we're actually going to be connecting to this specific port, but this is very important to know exactly which network you are going to be connecting to. So that's the Truffle config file. That's great, and we're going to press save and make sure that that's saved. Now what we're going to do is work a little bit on our contracts. So we're going to go into the contracts subfolder, and thanks to all of the great work that we just did before, we're literally going to copy and paste our Remix smart contract that we created in the Remix IDE. We're just going to literally copy and paste this into our contracts folder. So what we're going to do is we're going to create a new file. I say change state input.sol, and then we're going to literally copy and paste this into there. And pretty much everything is all the same. We have the same pragma solidity statement with our contract, with everything. And we've already tested this and we know that it works thanks to Remix, so we don't have to worry too much about that. We're going to save this, and we're just going to go back to this because we're not going to need Remix for the rest of the lesson. So that's all great. Now what we're going to do is we're going to go to the migrations folder, and we're going to just make a few modifications just to make sure that everything is all set. So in terms of the actual migrations statement, we're just going to update the Solidity version just to make sure that everything is all set. We're also just going to make sure that when we declare the migration, we have to migrate the smart contract locally and then deploy it to our blockchain network. So that's sort of how you take a file and then you put it onto the blockchain. When you migrate files, you have to basically put it and place it, and it's a transaction. So something that is a little bit interesting is you declare an owner. Now you'll see this in a little bit, but when you declare a contract and put it onto the blockchain, there's a contract address and then there is a account address. And it's a little bit confusing, but the contract itself has an address, and then the user is the one that puts that contract onto the blockchain. So when you create a cryptocurrency, for example, and we did this in our Pop-Up Fam workshop a while back. So when you declare a cryptocurrency and you push it onto the blockchain, you might create, I don't know, 10 million coins or a billion coins or something like that. That's going to be put into the message.sender wallet, which is the person that creates the wallet. So that'll have like your seed phrase, and you will use that if you are pushing something onto the blockchain. You're going to need that to connect to the wallet, basically just to tell the blockchain where the coin is going to be minted to. You need to be able to have an owner of that asset or that item. So that's where it's going to be, and you'll see this later, but when you declare this on the blockchain, the owner or the user becomes the person who owns that. It basically becomes like the admin of the deployer of the contract. And then you'd be able to do different things like modifiers, which we'll get into at a later point. But you could modify contracts and make maybe the message.sender or the person that deploys the contract, maybe they have admin rights to only do a certain function that no one else can do. for example. So that's just important with message.sender. But we have our owner, which we declare as message.sender, and that's the person that sends the contract to the blockchain. We then have a public last completed migration. So this is all kind of boilerplate set. We are going to have a constructor, and a constructor is just a initializer for Solidity. So we're going to have a public constructor. It's going to say owner equals message.sender, just to declare that from the start. Now under the modifier, we have a restricted and require, and we have to, and this is the actual modifier of just this specific statement. So we say that the message.sender has to equal the owner. And we also have that as a constructor from the start. So this function is restricted to the kind of owner. So we have that. And then we're going to have a function that says function completed, unit 256 completed, public restricted. And then that's the last completed migration equals completed. We're then going to have another function called upgrade that's going to be public for new addresses, and it's restricted. And when migrations are upgraded, that equals migrations new address, and then upgraded, set completed, last completed migration. Okay, so this is just our upgrade and migrations. There we go. Okay, and new address. There we go. Thank goodness for hard typing so that it knows exactly what we're trying to say, which is great. So thank you, VS Code. So this is great. So now we're going to be good here. This is just our migrations file, and this is going to be really important when we actually deploy this to Truffle. So that's great. Now something that we're going to want to do is just pop into our migration subfolder, and we're just going to make sure that this is correct. So we're declaring migrations with artifacts. Artifacts, it's kind of like the build folder. So when you declare something, it's going to be writing this as artifacts, requiring migrations, which is this folder. We have a function in module exports called the deployer. This is the kind of the message.sender, which is going to be the owner of the contract, the account, and the deployer with deploy on the migrations. So this is the one initial migration. We're going to create another folder called to deploy contract.js. And this folder, actually deploy contracts. Cool. So we're going to then declare a variable called change state input. We're going to make that equal to the artifacts require, and we're going to actually tell where to build this itself. So contracts change state input dot sol. But we also know that this exists here. So if we go back, so contracts and then change state input dot sol. So that's where that file lives. We are going to be requiring that specific file because this is going to be important to tell artifacts where to call from this contract. Then under exports, we're going to make that equal to the function deployer, and then we're going to go down and we're going to basically make this. Oh, and this should be module exports. Module exports. We're then going to say deployer dot deploy change state input, and it's already knowing that that's what we would want to add. All right, awesome. So that's pretty much this specific file that we're going to need, and this is going to be important also for the deployment of our smart contract. So now what we're going to do is we're going to save this. So make sure that that's saved. We're then also going to create a folder under SRC called ABI, but we're not going to put anything in there yet. But this is going to be important when we declare this contract and then get the bytecode. There's a specific JSON format that we're going to look for change state input .abi, and that's what's going to, we're just going to put some code in there. So I'm actually going to create a file. I'm going to call this abis.js. And we're just going to keep just some sort of boilerplate code for now, and you'll see where to add this in later. But we're going to put this basically as a empty array of JSON data, and we're just going to save that. Cool. So that'll be a coming attraction in a second. And yeah, everything looks pretty good so far. So we have our contract is there with our migrations file. We have our 2 migrations, and yeah, pretty much everything is all set here. We have our Truffle config file, which we've already updated there, and that's great. So now something that we're going to want to do is specifically now we're going to go back to our app.js, and we're going to work a little bit more on some of these functions. So if you remember from before, we specifically were we kind of put nulls here because we these are going to be on-click functions, but we haven't really done anything yet. So specifically what we're going to do is we're going to be connecting to our Web3 instance. And that's exactly how you're going to be writing it. So it's kind of in the same way that you'd be declaring something on an API. We're going to be changing our API to be able to connect to that. So we're going to do import. We're going to import Web3 from Web3. We're then going to also import that variable that we created. So with the empty array, change state input from ABI, ABIs. Let's clean this up a little bit. Okay, cool. And we already have our components from app elements, and we're pretty much good here. I'm just checking to make sure that we have everything, but everything's looking good. So now something that we're going to want to do is we're going to declare some variables at the top. So these are going to be the Truffle outputs post migration process. So we're just going to declare const web3. We're going to say new web3 given provider. And we're going to be basically working on this type of stuff once we deploy the contract. But I'm just going to put some placeholders there for now. So const contract address, and this is that contract address that I was telling you about earlier. We're going to need this when we are working on a specific smart contract. We're going to need to track which address the contract is deployed to. So we're just going to put like an empty string for now, and then const change state equals new web3.eth.contract.change state input / contract address. So this is going to be specifically the change state. We're passing in the change state input, which we get from the ABI. So this is going to be the ABI that JSON that is empty right now, but we're gonna get that from the bytecode, and then we're also going to pass in the contract address once we get it. And I'll just put 0x for now, just as a placeholder, or maybe I'll put 0x0. So that's great. Now what we're going to do is we're going to build a little bit off of our port. So when we are basically going to be checking for 2 things. So we're going to check if a Web3 instance is running on port 9545. So this is just going to be a literal check in the console to make sure that our Web3 instance is running, or if not, to let us know that we don't have something running. And this is just going to be helpful also for us in terms of testing, in terms of managing the state of our blockchain. We're just going to want to make sure that we are connected to this specific instance. And this is more important for testing. Obviously, with Truffle, you're not going to be having the local host port running, because you'd be having something deployed to the blockchain. You'd be able to read from it directly with the contract, and you'd be able to see it on Etherscan. But this is just helpful for us to be testing it. And this is a little bit important also as we are thinking about how we're building our blockchain application. We just want to be having these checks put in place. And then we're going to basically have a function that's going to then read and get data from our local blockchain. All right. So then we're going to have another function, and it's going to be the write, and it's going to be send data to our local blockchain. So these are sort of some of the specific things that we are going to want to have, and then we'll be able to call these when we are running these contracts. So specifically on the onSubmit or the onClick functions, we're going to want to be able to have those there. So under this specific check Web3 instance, we're going to do const Web3 check, and we're going to make that equal to a new Web3 instance. We're going to say Web3 check. And this is something that we can do off of the Web3 module, which we imported above. So up in here, Web3. So this is that Web3 JS pack. So we're going to do Web3 check. We're going to do set provider. We're going to say new. We're going to say new Web3 providers. We're going to say web socket provider because it's going to be declared on a WebSocket. So then it's WebSocket or WS // localhost 9545. So then we're going to semicolon this out. We're then going to do web3 check.eth.net /is listening. And then we're going to basically have two specific things. So basically, if this is running, then console log connection is successful. Otherwise, we're going to do a catch. We're going to pass in an event. We're then going to say console log. And then we're going to say, uh-oh, something went wrong here. And then we are going to then put the error log. So there's a space there. We're going to say plus, and then we're going to have E. So this is just going to help us track what is actually going on. And it'll help us kind of debug a little bit of what's happening. So actually, if we were to save this right now, let's see if we're able to get this spun up. So it might take a little bit of time for it to recognize what the Web3 instance is because we haven't used it yet. It's going to reload our application and let us see if there's something that oh yeah, so there's sometimes where you're going to need to, if you use the Brave browser, there are other extensions that are there. So we're just going to want to make sure that we're not having crypto wallets in there. That's something that can sometimes mess up your instance if you're using MetaMask. Now, what we're going to want to do specifically is switch our MetaMask. And I need to actually log into MetaMask. So I'm going to do that right now. And then I'll pick up the recording when I'm logged back in. So now that I'm logged in, I'm just going to comment out our Truffle outputs because we don't have those yet. And as soon as I add those back in, we're going to be able to see our dApp. So one of the things that we just added was this Web3 check, and this is going to help us see if we have Web3 running, specifically with Truffle. So the catch, or basically the error, is, uh-oh, something went wrong. So we obviously see that here. And then the connection is not open on send. So basically that means that we are not running an instance of Truffle, which is true. We've only installed it into our application. So that should, of course, be happening. And that's why it has that error in the console. So that actually is good because it's tracking exactly what we're doing, and it's actually seeing that the WebSocket has failed. So that means that we're all set there. So now what we're going to do is we're going to be building out these last two functions. So we are going to do our read function. So it's going to be an async request. We're going to say const handle get. We're going to say async with an event. We're going to pass in this arrow to create an arrow function. And then with this event, we're going to say prevent default. We're then going to say const result to create a variable called the result. And that's going to await a change state based on the methods of get call. We're then going to set get state, which is that hook up here. And we're going to say get state. We're going to do this on the result. And then we're also going to console log our result. So then we're going to put this handle get later. So we're just going to finish writing out that function and for the right one. So now for write, that's also going to be an async await as well. So we're going to say const handle set, and handle set is just going to be a function that we use with state. So we're going to say handle state, handle set equals async. We're going to pass in an event. We're going to make an arrow function again. We're then going to say e prevent default. We're then going to say const accounts to basically create a variable of the accounts of the users. We're going to say await window.ethereum.enable, and this is how you would enable Ethereum in the browser. We're going to say const account equals the first account. So of the accounts that we have in our list, this is going to be the first one at index 0. We're then going to say const gas equals await change state. On the methods, we're going to set state dot estimate gas there, and then we're going to say const result equals await change state. On the methods, we're going to set state here, and then we're going to say send, and this is how we're going to actually send a transaction. So it's going to be from the account that we declared up here at the index 0 with gas. I'm just going to get rid of that pop-up with the escape key, and then we're going to actually console.log the result, just so that we can keep track of things. So these are our two read and write functions. We're then going to put those below. So we're going to put that under for our submit. So under where we had null for on submit, we're going to say handle set, and that's going to be this function. So this is going to be that write to the blockchain. We're going to be putting in basically this value, and then we're going to be basically sending it to do something. So on change, when we pass in this event, we're going to pass in an arrow. We're going to say set state, one of the hooks that we declared above, and then we're going to do event.target.value, and then that's how we declare it out. So that should be all that we need to do. And yeah, on change is good. We have all that set up. That should be set. And then we just close out that bracket, and we can actually even just be a little bit more efficient and just say like that, just because you can do that in React. So just to make it a little bit cleaner. And then we close out the label. We then have for input type.value. And we can actually just clean this up a little bit more, just so that looks like that. And for form, we close out form. Now for this onClick button, instead of onClick, we're going to say handle get. And that, of course, is what we're calling up here. So that's that read. So to get data from the blockchain, and then we're basically requesting data from the system that we create with Truffle. So, or really it would just be the blockchain in general, but yeah, handle get. And then that's the button, and that's our get state button. And then when we get state, that's going to be there. So these are pretty much all of the functions that we're going to need to have here. I'm going to give this a save, and of course change state is not ready to go. So what we're going to need to do is actually uncomment this out, and we're going to be basically taking out some things here. So yeah, I mean, it just won't compile because it needs these things, and then it also needs the other things as well. So we're going to definitely need those and then it'll be able to run. However, it's not going to like the address there, so I'm actually going to just put in a sample address. So just because it's looking for a specific address that looks like this isn't actually the address that it's going to be. We're going to actually change this, but this is just a filler address for now. So now we're able to do this, and this actually it's going to error. It won't actually work because it's not connected to anything. And when you set state, obviously it won't work. And then when you try to get state, that won't work either, and then it'll error. So just to kind of give you a little bit of a heads up that if you try to do this yet, it won't work because nothing is set to work because it's not connected to the blockchain yet. But this is exactly what we want to be doing, and this is pretty much all of the code that we need for our application to be running. So now what we're going to do is we're going to be now going back to the terminal window. We already have installed Truffle into our project, right? So now what we're going to do is we're going to now need to do some Truffle things. So what we're going to do is we are going to initialize Truffle, basically create a Truffle console window. So we're going to say npx truffle develop. We're going to press enter. And as soon as we create the npx truffle develop, it's going to provision a number of accounts for us here. And these are the 10 accounts that we have readily available for us to use. And this is going to be how we actually will log into our account. So, and it also gives you accounts, and then it gives you private keys as well of those accounts. And it also gives you a mnemonic so that you're able to log into this if you wanted to like use like Ganache or something like that. So I'm also going to open up another terminal window, and I'm going to cd into change state dApp. I'm going to also run a concurrent window that will log the output in what's actually happening in the blockchain. This is actually kind of like the cool part, I think. It's kind of interesting, fun to see. So npx truffle develop --log, and just again so you know, I have Truffle behind npx, so that's why I have to say npx truffle develop. Depending on how you install the CLI, you might just be able to say truffle develop if the CLI is configured to have that. But just so you know, that's why I have to say truffle or npx or npm truffle develop. That's just why. So when I run this is now going to create a kind of like a block explorer in a sense, but it's a list of all of the things, and it's connected specifically to my Truffle develop session. It knows that that's what's happening, and this is going to be logging all of the outputs based upon my Truffle instance here. But yeah. So now that it's connecting to my Truffle develop session, I haven't actually run anything yet. But yeah, that'll be running and configuring as we go along. All right, so we've made a lot of progress so far. So now some of the fun stuff gets to happen. So what we're going to do is we want to be able to connect to this port that we declared. And you might remember this with the Truffle config file. So we created this port 9545. We kind of just added that and we said, that's going to be the port. But how do we actually connect to this? So what we're going to do is we're going to go to MetaMask. As soon as we're logged in, you can just be logged in any account. This is actually one of the Truffle wallets that I have that we're going to be using. But what you're going to do is you're going to click on the MetaMask extension. You're going to click on these top 3 buttons. You're actually going to click on the account at the top, and you're going to go to settings. And you're going to scroll all the way down to where it says networks. Now, these are all of the networks that are pre-configured with here. So you have Ethereum mainnet, and these are the testnets that I had described earlier, but there's the Robson testnet, the Rinkeby testnet, Galeri testnet, Coven testnet. There's a localhost 8545, which comes as default. There's other ones that you can add. So I have like the Matic mainnet, Polygon testnet. These are currently building some stuff with Polygon. So I've been using those, but you can also declare other instances. So I have a Ganache, basically localhost port that I created when I was working with the Ganache GUI. And then I created also a Truffle localhost 9545. So what you're going to do is, these might not exist yet. You're going to click on Add Network, and I'm just going to show you what you put. So you sort of want to use a descriptive name just so that you remember exactly what you're doing. So I have localhost 9545 with Truffle. That always just signals to me that, okay, like anytime that I'm connected to this environment, it's the localhost for my Truffle instance. And then in terms of the new RPC URL, this is going to be 127.0.0.19545. That's basically a combination of the host plus the port. Actually, I realized it just closed out for us, so I'm going to get that back. We go back to networks. We go back to 9545 Truffle. So it's a combination of the host with the port. So that's just like a little bit of how that's being configured. So it's, again, like you're going on the development server, there's a host with the port, and then that's how they connect together. For the chain ID, this is just used for signing transactions. It has to match what you'd have. So I have 1337. That's just the default chain ID. And then the default symbol is ETH, because this is an Ethereum testnet that we were trying to simulate. So once you have that, you're gonna save it or add to your network. And then what you're gonna be able to do is then on the drop down, you then go down to click on it. So obviously, like, it's going to now connect to this. And what's really cool is, because we created this third instance, and remember I had done npx truffle develop -- log. So now I'm able to track all of this. So this is basically a running blockchain tracker, and it uses the development server from Ganache, and now is actively adding block numbers. It's being able to check things as I interact with certain things, such as get state. We haven't actually compiled it yet, so it won't actually send anything. But as we would get state, there would be a transaction that comes up. It would be a read request, and set that. Also, if we do set state, that would be how it would come up as a transaction once we run it, and we'll be able to see that very soon. So that's pretty cool. And now when we refresh the dApp, it's actually now saying connection is successful, which is awesome, because that means that our network is connected. Our check Web3 instance is actually recognizing that we have run this, and it doesn't say that, you have an error. Now it says connection is successful, which is awesome. So now what we're going to be doing is we're going to now be doing some fun stuff. So I'm going to go to my other Truffle development terminal window, and I'm going to be writing, because now that we're in the development console, I'm going to say truffle migrate reset compile all. And what we're basically doing is taking our Solidity file, running it with the migrations file, which is this, and it's basically going to be taking in these migrations, and then the initial migration is this file, and this file, which is the deployment. So it's basically packaging all of this up, and then basically sending it to be deployed by the message.sender, which is the owner, to then be deployed onto our local environment. So if everything worked out, which, fingers crossed, let's hope that it did, this should work out well. And I'm going to actually make this a little bit bigger just so that we can see here. So now what we're going to do is we're going to run this. It's going to compile our contracts. It's compiling everything here. It looks like it was compiled successfully, which is awesome. And you get to see that the artifacts are written. Okay, so a whole bunch of output just happened, and we're going to unpack all of this. So when you run this, right? So again, we're basically clearing out the whole Truffle instance. Basically anything that had been compiled before, we're basically doing a reset. And then we're going to be compiling all of the contracts that we have in our contracts folder. So we're compiling the contract, specifically our change state input.solidity file, and then our migrations.solidity file. These artifacts are written to our folder, and they go under contracts. So those exist. Let us find where they are. So build. So under the build folder. So we're going to get some JSON files here for each of these contracts that we wrote, and we'll get into those in a second. We're going to start the migration on the network develop, the network ID with the block gas limit, and then this initial migration, that's what's being deploying the migrations. So there's a transaction hash, and if you remember from the when we're going on Etherscan, that's where we're able to see these transaction hashes for all of the things that are written on the blockchain. Now, this is obviously with block 0. This is the start of it. There's that contract address that we were talking about before, and then there's a block number, block timestamp. There's a balance, and this is basically the account that we had just deployed from. So there's some gas that was used, there's a price, and we migrated to the chain, saved the artifacts, and the total cost was 0.001 ETH. Now deploying the contract, and of course this is just test ETH for now because we're using the Truffle accounts. Now deploy contract.js. When we deploy the change state input, we're using, again, like we're deploying this as a transaction. There's a transaction hash. This is specific to our smart contract. We're going to want to make sure that we track this contract address because this is what is different from the actual account. So if you look at under Truffle, there is the first account, which is 0x7FC. That's this address. So 7FC1. That's the account, and that's different from the contract address. We're going to need that contract address. If you remember from before, we're going to want to put that in our app.js file. So the app.js file, we're going to actually drop this in there. So we're going to copy and paste. We're going to replace that, and that's what the contract address is. We're going to need this when we change the state. Basically, think of this as like a public API key. It's not really a key in a sense because keys you sort of keep those more private, but in a sense, it's just a public verification of the contract that we want to track. So we're going to be just basically using that, putting that in there, and then we pass that in with the contract address. With change state, with this change state input. And we're going to get that from the ABIs. So we're going to get that in a second because that's the output from our JSON file. So when we save this migration to the chain, we save the artifacts. Again, like this was, 0.001 ETH. So now it sort of, shows that it was all deployed, right? But now we have all of these things. So this is kind of cool. So we get to actually see all of the things that were just happening. So there are some transactions that are happening, and these are with the transaction. There's a contract that's created. There is the gas usage. There's the block number, the block time. There's a lot of really good stuff that we are getting here. And in terms of the get transaction receipt, so this is just verifying that all of the stuff that we're doing is working. And this is updating in real time. This is like 20 seconds ago, and that just added. So this is kind of our living, breathing, blockchain instance that we can track. So that's great. And now what's really cool is what we're going to be able to do is we're going to be able to actually interact with this contract in a second. So so this is pretty much everything that we're gonna do. Once we add this contract address, we're then going to be able to write to the blockchain. So I'm going to give this a quick save. This is still running. I'm going to give this a save. This should refresh the page. And one of the last things that we're going to do here is we're going to update the ABI. So when we deployed our contract, and this was a transaction that was hashed, we then had, if you remember, we had a build folder that created a bunch of output. So when we specifically got this build output in JSON, we got basically bytecode. There's this whole long file that gets generated that basically has all this information of this contract and what it can do, sort of the parent and the children attributes and permissions and that type of stuff. And this is basically a file that we're able to use. So we're going to basically call this specific ABI, and we're going to basically gather everything in this array up until that bracket where the metadata and then the bytecode starts. So we're going to take this, we're going to copy it, we're going to paste this into our abi.abi's JSON file, and we're create an object of the state change input. So this is actually how our contract is going to know what we're doing, and basically just certain parameters that will be helpful for this to actually read and write to the blockchain. So we're going to save this here. That's going to cause this to refresh. And as soon as we're able to have this be connected, we should be able to have this all be running. So we're already logged into the account, which we see. We have 100 ETH. So we're gonna actually test this right now. So let's see if this works. So when I say get state, all right, so it is now checking this in real time. And I actually want to show you all what this is happening so that you guys can see. So I just did an ETH call. And whenever I call it again, it's net listening ETH block number. So I can call this, any number of times, and this is going to be basically updating, in real time with the blockchain. So now let's see if we can try to write something to this blockchain. So as I write stuff in, it's listening to events, and this is just basically with the Truffle instance. It's tracking based upon this API call to see when I'm putting something into the input. So I'm going to show you how to install one of the wallets into MetaMask so that we can write data to the blockchain, because it's fun to read it, but let's actually add an account to write something to it. So I'm going to take one of these accounts. So when I did npx truffle develop, it provisioned those 10 accounts for us. So I'm going to pick, let's say I'll pick this one. So when I go down, so I'm going to pull, so it exports the seed phrase as well as the address. So I'm going to take these private key. I'm going to insert this into MetaMask. So when I have this here, so I'm going to import account. I'm going to paste my private key in here. It already knows that it has 100 ETH. I'm going to now connect. Now it's all there, which is great. So now I'm connected. So now I'm just going to give this a quick refresh. And if everything went well, so I'm going to just check the state. All right. So now if I'm going to write, let's say that I want to write set state with 5. So let's try to write that. So the transaction is going to pop up, and I'm going to confirm it. And I'm actually going to edit the gas just to, so something that you can do is you can basically edit the priority. I want to make this go super fast. So I'm going to spend more ETH to make it go faster. And I'm actually going to go back here to the blockchain developer console so that we can see. So as we are developing with this, I'm just going to move that a little bit out. So as we're writing to the blockchain, this should come up as a transaction. I'm just going to make it high just to save it, make it go a little bit faster. So as soon as I confirm it, if this all goes through, which it looks like it did, it's going to come up as a transaction, and then it's going to give a whole bunch of information about what actually just happened. So that's what I have in the console as the output, and it looks like it all happened. So what ended up happening was we had a transaction. There was some gas that was used. Actually, I'm going to expand this a little bit more just so it's a little bit easier to see. So that's where you have the gas usage, the block number, the block time, and of course you can see that this stands out because this was just, ETH listening, ETH block number, and then there's this transaction. So what ended up happening is there was a transaction hash with a transaction index, block number, block hash, all of these great things, and events coming from this specific account, which is this address. So that's the FD2, and you can see that it's from here. It's writing to the contract address. So you'll see that up here. So 9DEC. So that's where you can see that I'm going from this address and I'm writing to the contract address that we declared above. And this is of the change state input smart contract. So now, and of course this creates an object with a certain value. So what we really want to hope for is that when we get state, this number should have changed. So it should go from 0 to 5. So let's test it. So look at that. So now we did ETH call to the blockchain, our local blockchain instance, and now it's 5, which is super awesome. So now let's see if we were to write 50 and we wanted to set state. So now we're going to run another transaction. I'm going to edit this and I'm going to make it go fast again. And then when I confirm it, if this is happening again, it comes up as another transaction, and now it's 50. Now, if we wanted to say 500, we're going to do set state. We're We're going to make it fast. Guess again. We confirm it. And now it's 500. So now you can see how what's really fascinating and very cool about blockchain is that all of this data is immutable. So I'm writing and updating the state of this specific input. No one else is able to change this unless they have access to this specific function. And what I mean by that is we're going to go back to our smart contract for a second. So in our change state input, so we basically have this public function that creates this state input. And we also have this that allows people to write to this variable, which we declare as v, which is the state input, which is a number, which is a unit256 integer. We also have a public view function to be able to get that input. Now, anyone that is able to access this contract is able to then go and do these things. So let's actually log into one of the other accounts that we have. So we have here, let's just try to go to the other one. So account number 9. So when we say, and let's actually refresh the dApp just so that we can see exactly what we're talking about. So when we say get state, do you see how I just logged into a completely different user and I was able to get that same state? So this is the very powerful part of blockchain, is that this piece of data is immutable, that I was able to write this specific number onto this specific variable, and anyone that has access to the same network, again, think of like with MetaMask, anyone that's connected to this local network or this blockchain network in general, that's able to have an address that is validated and verified within the system, they're able to then also get that same information if they have access to that same call. Now, we could do something that's more advanced where we could say maybe only certain types of accounts have access to this specific set function, but everyone can get it. Or maybe there's only certain people that could get this function, but everyone can write to it. So there's different ways that you can optimize the smart contract to fill your needs. But I think that's one of the most powerful aspects of blockchain to me, is that all of the data is immutable, so that people are writing to this public ledger and then people are able to verify that public ledger. And of course, I didn't even need to, like log in and verify that type of stuff, because the system is verifying that this account is also a part of that same network. So that's why I was able to get the 500 that I had set in the previous account, because they had already run the transaction, and then I was able to just read from the state of that variable input. So this is a pretty cool aspect of blockchain to me, and hopefully this was helpful for you all to see exactly how the blockchain can be updated, how you can write something to the blockchain, how you can manage smart contracts, and really build a very smart technology. And even just sort of thinking about where this could this expand from, we could actually turn this maybe into a credential creation platform. So when you write, and let's say that you verify you are a React expert and you are really, really good at React and you passed the React certification program, you could then maybe create an item, maybe it's a credential, and then that has a certain amount of inputs with your name and your wallet address and maybe certain things, and then you could write that credential to the blockchain. Now anyone might be able to get the state of that specific credential to verify that it's really yours, that you got it. But you specifically are writing something to the blockchain based upon credentialing, or maybe information that needs to be verifiable amongst trusted parties, or parties that want to be able to trust each other. So that's where you're able to then take this specific type of smart contract and then build on it. All right, so one of the last things that we're going to do is create a sort of check on the status of the blockchain, and also we're going to be learning a little bit about promises using the Web3 API, and then building off of that to create sort of a visualization that we are connected to our blockchain and we know which port we are exporting this from. So what we're going to do is we are going to do a little bit of things with console log, and then we're going to actually build a visual interface. And you probably were wondering what the React loader spinner was for. So that's actually what we're going to be building for. But just bear with me while we go and do some things with the Web3 API. So when we were already using the Web3 API, when we created this Web3 check, we then had a set provider with a WebSocket provider on this specific host. And then it's checking to say if we have a connection, that's great. Otherwise, something is problematic. So when I'm able to get the state and it's successful, and I'm able to get that it's 500, that's because this is working correctly. Now, let's see like what else we can build off here. So I'm gonna just make the last thing. So check the promise statement and confirm it's 9545 on the port. Okay, so we're gonna first do web3 check promise. We're then gonna do web3 check.eth.net.is listening. Then we're then going to do arrow statement, do console log web3 check dot provider dot URL, and specifically what we're going to do after that is we're going to just save that, and we're going to see if it's returning anything back. So let's find out. Okay, so just to kind of go back a little bit, so I'm just going to undo the URL so that you can see. Okay, so when we are building off of this API, when we say is listening, so that's just checking to see if there is that instance of Web3, which we already set with the Web3 check. So when we're running Web3 check with is listening, then we're passing in a promise to say like, if this is happening, then run this and say connection. Basically, promises are for something that you expect to happen but hasn't happened yet. Sort of like async await. You just want to make sure that something is going to be happening in the future, and then you want to be checking for that. So when we are building off of our Web3 check, but really this Web3 instance on our computer, what we're really actually getting is a whole bunch of data back. Now, this specific URL is the localhost 9545. That's really our WebSocket network, and we already provisioned this with our MetaMask when we were creating the network, but then also when we created the Truffle instance, and we specifically denoted the port on our network. So then when we actually call that specific provider, we're going to get a whole bunch of data back. So there's different connection data points here, specifically with that URL. There's also recommendations, there's headers, header objects, there's different events, there's different request queues. There's a ton of different opportunities to really dive into data here. Now, specifically with this URL, where you just want to specifically call that back. So we just want to confirm also that it's calling this back. So this is from line 32 and this is from line 32. So that's great. So that means that this is pulling correctly, and this is the WebSocket that we would expect. Now let's kind of try to dive down a little bit more into how to actually just because I just want to track the 9545 because that's really all that I'm focusing on right now. So when we have this URL, we're going to then so if you have this string, which is what is exporting, if you want to take just the last 4 characters of that, we're going to do slice, and then we're going to do -4. And that's going to basically go through the string and then take off the last 4 characters and then keep those characters. So when I run this, we should just get 9545 in the console. And it looks like we do. So that's great. So now what we want to do is then as we get this 9545, we've already confirmed that this is working and that this is correct. Now what we want to do is pass this into a state variable that will then use to render a state checker. So what we're going to do is we're going to say then again. So it's already, if this is listening, then we expect to get something like a URL. And then we're going to do the same thing, except we are going to then set promise fulfilled 9545. And this means that we're going to have to, because we're going to be setting this variable to be that, so we're going to want to set the state here. So we're going to go up to this row and we're going to say const this and then use state false, because we want to actually have this initially false. And when we have ever like a set promise fulfilled, we want to have something that will be the variable. So we're going to do promise fulfilled and then set promise fulfilled. So that's great. Now what we're going to specifically do after that is we are then going to run a state checker. So I'm going to also just save this just to make sure that this is going to work out fine. So it looks like it should be good. All right, great. So now inside of input box, I want to create a blockchain status tracker. So I'm going to say blockchain status. And inside of this, I'm going to put a grid. And we're going to put in some properties. So this is calling from the React loader, React loader spinner package. So we're going to put in some different variables. So I'm going to say label equals loading indicator. We're then going to say color Alice blue, and height we're going to say is 30 pixels. Okay, cool. So now, if you remember from styled components, we don't have this as a styled component yet. So what we want to specifically do is import this from the above. And we're also going to want to do exsc in the app elements. We're going to paste that value in, and then this is going to be a styled div. So now in our app components, we're then going to have some properties here. So I want it to go right in the corner because this is already taking up a lot of space at the top. So I want to put this square in the bottom right. So what we're going to do is we're going to say float right. We're going to say right 0. We're going to say bottom 0. We're going to say margin bottom 20 pixels. Say position absolute. We want to say margin right 0 pixels. And what else do we want to say? We want to say fill. We could just say I think we were originally saying Alice blue. Yeah, so let's just put that there. Okay, awesome. So that we're going to save that. We're then going to save this, and it should appear right in the corner, and it does, which is great. So now this is I just rendered this out, in the space, and that's not really that exciting because of course I coded it there, so of course it would show up. But now let's see how we could add this into our promise to actually make it connect based upon data that we are passing in. So what we're going to specifically do is create a conditional render on this specific thing. Now I'm going to do a mapping. We're going to say promise fulfilled equals 9545. So if the promise fulfilled equals 9545, then we're going to show this. Otherwise, we're going to show something else. So I'm going to bring this down. So this is just going to say like something just for now. And then we hold that there. And then that's pretty much it for the conditional render. Now, what we specifically want to do that I think would be kind of interesting would be if we can actually just move this up a little bit so that it's really just rendering this. So I would like to actually change this to say, maybe make it red. So if this is not true, then show red. And that could be helpful as a warning. So if someone is, someone isn't using the 9545 port, then this would be signaling red. So let's see how this would actually work. See if it works and goes according to plan. Oh, that's good. So it looks like it's initially checking that it would be red, and then otherwise it goes to white, or the Alice blue color, and then it flickers. And if we were to make this not true, so if promise fulfilled does not equal 9545, then it should be flashing in red. So it'll look like that in case these aren't true. So this is why it's important to, first of all, get the promise first and make sure that we understand how the promise is interacting with this blockchain and being able to explore the Web3 API along with tracking our provider to then conditionally render items based upon that specific state. And then, of course, we're able to, just scrolling through this file. So then when we know that this is the expected value, we can then set that value as this, put it in our state, and then push it in as if it's true, then show something else. So yeah, so we can obviously remove this back. We'll save it. And it's just recompiling. And it's just going to rebuild again. It's going to check to see that. And looks like we have it back to where it's supposed to be. So this is great. So we have pretty much everything that we need here to make it all work. And I think that's one of the exciting parts of development, is thinking of where you can take development and push it forward and move it forward. So and build on it as a foundation. But we just did a whole bunch of stuff today, and I just want to really just take just a moment to really appreciate all of the learnings that we just had together, and how we just built this dApp that combined Solidity, smart contracts, Truffle, Ganache, Web3.js. We added a lot of different technologies into play, and styled components, of course, for styling. But yeah, I just wanted to take a moment to just congratulate you on going through this. And this is really, I hope this is eye-opening. This was really eye-opening to me when I was going and actually creating this workshop. And I hope that this was actually helpful for you all as well, to think of where you can take your career and where you can take your growth as a blockchain and a Web3 developer. The space is rapidly evolving, and it's literally just the beginning of this. So there's really no shortage of a need for blockchain, cryptography, Web3, and full stack developers. So I hope this inspires you and motivates you to go and build your next dApp, or maybe start writing smart contracts. And this is just hopefully the beginning of an exciting journey for you in Web3. And of course, please feel free to reach out to me. I'm really hopeful that that if you have any questions, I'm Brian H. Huff pretty much on all social media. And yeah, and just feel free to reach out if you have any questions, if you have any comments, if you ever want to talk about Web3 or getting started in Web3. I've made some TikToks and some LinkedIn and Instagram posts and blogs about this. So hopefully that, and YouTube channel videos as well of how to get started, how to build your career. But there's a lot of really exciting stuff that's happening in this space. There's cryptography, or like with cryptocurrency, there's NFTs, there's DAOs, there are people that are just building decentralized applications with real use cases for industry. So yeah, there's just a ton of stuff happening, and I think one of the best aspects is really to just start. And by you even being here, you are showing up and starting. So this hopefully can be the beginning of your exciting career, whether it's Web 2 or Web 3 or Web 4 or Web 5, but at least to start building with advanced new innovative technologies. So thank you so much for taking the time to watch this, and I'll see you all next time. Thanks everyone. Bye.